Kindly go ahead. Okay. Good evening and welcome, the distinguished speakers, all the participants, and my colleagues from different organizations like South Asian Lightning Network, African Center for Lightning and Electromagnetics Network, Center of Excellence in High Voltage Engineering and Engineering South Africa, and Jambian Center for Light Information and Research. It gives me an immense pleasure to welcome you all to the long-awaited 2 days seminar on scope and opportunities of research on various facets of lightning. This program is the result of overwhelming responses and feedback from the participants, particularly graduate students, engineers, and young scientists who participated a series of online programs organized by us during past few months on protective measures against lightning. Actually, we have covered various issues on lightning, and we are very glad and privileged to have eminent personalities from around the globe who have devoted their lives to understand the various facets of lightning. We are very happy to share that the organizers have relentlessly and voluntarily been working towards mitigating the loss of lives, livelihood, and property damage due to lightning. This program is one of such efforts to provide the knowledge about the scope opportunities of research to the graduate students, engineers, and scientists to apprise them about the various facets of lightning. So once again, I welcome you all on board, and particularly we are very much thankful to the eminent speakers of today's and tomorrow's program. We are very, very thankful to you. And a bit of announcements for the participants. For the sake of continuous and good presentations, kindly all the participants are kindly requested to turn their videos off and mute themselves. For any queries and questions to the distinguished speakers, kindly write your queries in the chat box that will be addressed during the question and answer session. And all the distinguished speakers are also humbly requested to limit their talks within the time allocations. Actually, you might have noticed that we have so many speakers, and we have limited your time of presentation by 12 minutes and 3 minutes for discussion. But as we try to take the discussion at the end of the during the question and answer session, so you can extend your time of presentation or discussion or sharing for 15 minutes. So I would like in this connection, or as a first speaker, I would like to invite Professor Mohammad Zainal to be ready with his presentation. Professor Zainal, uh, small
Yes,
background.
yes,
Yeah, you are there. So, Professor Zainal received his BSc Engineering degree in Electrical and Electronic Engineering from University Putra, Malaysia, and PhD degree in High Voltage Engineering from the University of Manchester, UK. Currently, he is a strategic higher professor at the Institute of Power Engineering, IPE, Unitin, and a professor at the Faculty of Engineering, UPM. He is the founding director at the CELP UPM. Professor Jainal is a fellow Academy of Sciences Malaysia, ASM, and IET. He is also uh, an IEEE Power and Engineering Society, Energy Society (PES) distinguished lecturer in the field of lightning and high voltage engineering. To date, he is he is he has authored and co-authored over 400 journals and conference papers. His research interests include high voltage engineering, lightning protection, electromagnetic compatibility, power system, transient uh, well, transients and renewable energy. Professor Zainal is a professional engineer, a chartered engineer, and a professional technologist. And currently, he is the chairman of the National Mirror Committee of IECTC 81, Lightning Protection, and local convener of MNC SIGRE, CFO on system technical performance. He is also an advisory board member of the National Lightning Safety Institute (NLSI) USA and research advisor of the African Center for Lightning and Electromagnetics. So I would like to welcome Professor Zainal to present his uh, presentation. Uh, Professor Jainal, it's over to you.
Thank you very much. Thank you, Dr. Sharma, for generous introductions. Welcome, everybody. It's about 9 p.m. here in Malaysia, and I believe it's going to be the same for different parts of the world. You have most probably in the morning and also in the afternoon. Anyway, I have about 12 minutes, and I have only about 5 to 6 slides that I'm going to share regarding the research opportunities on lightning protection and high voltage engineering. So basically, these two, I would say, field is very much interrelated as far as from the research perspective is concerned. The first question is basically that comes to our mind when it comes to research. There must be something that drives us to do the particular research of interest. I'm just going to share, for example, like in Malaysia, and I believe it's going to be some cases in different part of the world as well. Sometimes our research is very much driven by the policy and the direction from the regulatory body. So in this case, in the case of Malaysia, for example, we have the Energy Commission, which is govern all the electrical and safety aspect of the power utility and also the safety of the public. And I believe Prof. Chanima also remember very well when we first engaged with the Energy Commissions way back in 2011. So this circular, I'm so sorry, is in native language, in Malay. But prior to the release of the circular at that time, so we have different meetings, a series of meetings with different stakeholders before it comes into, it's not that enforcement at that time, but it comes into the picture as a circular, which is, ask the consultants, ask the vendors to use the IEC 62305 in design the lightning protection system for buildings. And then very recent, that from the circular, it becomes an enforcement. It's much more powerful as the direction paper approved by the cabinet. That against now it become mandatory, for the consultant, for the vendors, for the engineers to adhere to the IEC 62305. So this actually helps us to drive, more research, because if you refer into the, to the guideline, also to the standard, I think there are a lot of information, there are a lot of components that need to be addressed and need to be assessed, as well as need to be investigated. So this is how we translated our research, being standard or statement in the guidelines, into something that worth, for the PhD and also for the masters. There's also research, that's actually driven, by the current trend or the, from the industry. For example, through a learned societies or working group, such as SIGRE, IEC, and also IEEE, that actually comprises of various, experts in, from various fields, from various country, from various background, in order to come up with either a brochure or either a technical, guideline and so on. So I think this is actually, what has drive, I would say, has driven, the I think both either the researcher and also the industry, in establishing either the product or from the perspective of the research as well. So the third thing, I would say the driving factor is in terms of sometimes our research is very much uh, problem oriented that requires a unique or a specific solutions. Some of the cases, for example, it's kind of like top-down problems requested by the utility, to look into certain aspect of the say the performance of their transmission line, for example, or in other example like maybe the railway engineering, for which they required their asset to be evaluated or to be investigated. That again, how we actually package it, to come to become as one of the research component, as I mentioned earlier, which is worth, for about like 3 to 4 years, PhD or master students, to be graduated. So this is some of the thing that is very much, help us to come out, to propose a new research area, new research objective, and so on. The next, I would say, factor is the public safety. Sometimes with a lot of issues, a lot of cases that has been reported. For example, I think either in worldwide or even in particular countries, that actually again drive the regulatory body or the ministry, that actually triggered them into looking. This public safety aspect, take it more seriously, and from that perspective, it's also has actually triggered down, to the researchers in order to come up with something, to look into, say, for example, why we are having such problems, and how we can actually mitigate such a problem. Then when it comes to public safety, we have to be prepared, with certain kind of like framework, guidelines, as far as the public safety is concerned. And of course, there are so many other things that actually drive, the research. From different perspective. This is a very quick example. This is one of the paper that we have, published this month. This problem is part of the issues that's been facing by the power utility. And it's very simple problem, not very simple problem, very simple statement in the sense that does it save, for the public utility or for the client, for example, to install or to have a brace, as a support structure to the, the transmission tower cross arm in this case. The problem triggered because of they have to actually replace, the wooden structure or the wooden cross arm that has been used or that has been in service for the past, 30 or 40 years. And the issue is that with the limitation of the space that they have, and then there's an idea to use the, FRP composite cross arm. It's fiberglass, what we call the insulator cross arm. And what happened is that because of the design and because of the loading, with the way of the conductor and so on, and then that's become an issue. There's a tendency of the cross arm going to be broken, and for that reason, they acquired, the structure, the out whether it's safe to have the support brace to be installed, and what kind of material, whether that is going to be plastic or whether that is going to be metal. So, what actually we have done, we have modeled the system using the finite element, using the ANSYS or console, and under the different conditions, which is again, this different condition, for example, is regulated by their manual or like the design manual. And then we establish, the value, we call it the critical flashover, for which, depending on the distance of each point that we have actually identified, and we have to make sure that whatever the voltage, when we do the testing or when we do the simulation, it shouldn't actually exceed whatever the corresponding value that we have estimated. Because the CFO or the critical flashover is U50, which is a 50% chance of the insulator or the point of interest that can possibly cause arcing to the system. And the next one, what we did, so when we model into the finite element based software, and so we actually try to look into the field distributions and also the potential distributions from different perspective, under different, in the case of back flashover, for example, when lightning hit directly to the structure, or in the case of when the lightning hit to the phase conductor. But of course, I think this particular subject or this particular application on the transmission system or the transmission and distribution, I think is going to be covered most, by Prof. Rashidi later. But again, this is how we translate the issue as problem-oriented, as requested by the utility, for example. And we have, it's not just we model, but also we try to quantify, the result. And finally, we can conclude whether that is going to be safe and how safe when we define safe. So what will be the margin? What will be the safety criteria that we have to actually, consider in the design? So as simple as that. And finally, based on at least from the electrical perspective, then that's allowed the utility to have a much better decision to be made. But of course, when it comes to again the high voltage engineering applications, I think it's pretty much you can't run away from being interrelated with other fields as well, with other domain as well. So as far as the the future or the potential research, as I mentioned, I think most of the cases is actually driven by the needs from the public, from the industry, and also at the interest of the group of experts in CGRE or in IEC, in IEEE, and so on. So it's not just what we have currently or what we are currently working on, but also this is the perspective of the way forward. Some of the projects that is very much, I would say, in line, with whatever the guidelines, whatever the technical brochure that have been presented. So the first one, the GIS-based risk assessment analysis for asset management. I think this is the new trend. It's not many people, because GIS application is very much known for the civil engineers, to do their risk analysis and so on. But we have taken it, differently. We have taken it into our domain and tried to actually, look into the potential of expanding the application of the GIS-based risk assessment. And we have demonstrated, in terms of the applicability and also for the future asset management. It is quite interesting, to see that the advantage, or I would say the advantages of the GIS for several reasons. You can have all the historical informations, to be embedded, in the solutions, and you can even sort of like carry out the aging, studies for any asset of interest. The second one, in terms of the installation coordination, yes, installation coordination itself is quite new. It's quite established. I mean, from the perspective of transmission and distribution performance. but then when it comes to the railway engineering, for example, we have different arrangement. We have third rail, we have fourth rail, and to suit, the what we call the utilization in different countries. For example, Malaysia is among the I think only three countries in the world that is currently using the fourth rail system for our MRT, mass rapid transit system. So this again another opportunity to look into this particular perspective, from because I think it's quite fair to say this particular work is very much relevant to Malaysia being one of the top country with line density in the world. So the issues is either the direct hit or either the indirect strike due to induce and so on. So it's really worth to be investigated. The third, I would say, project or potential works that can be carried out in terms of the high voltage testing and measurement on the lightning protection system component. Although we do have the IEC 62561 -1 until
Zainal,
-7 or dash. Yeah, can you hear me?
yes. May I request you to wrap up in a couple of minutes, 2 minutes
All right.
more?
Yes. Yes.
Yeah.
So, so this again another opportunity to look into. The fourth one, in terms of the lightning surge analysis and connection, I think even from the security perspective, they have actually established a working group to look into the large scale solar. So, but the investigations due to lightning is something that's again really worth to be looked into. The fifth one is on the transient fault detection. There's again the utilizations of the artificial intelligence, also big data in terms of characterizing and classifying the fault due to lightning and other transient. The next one is on the insulation strength of HV equipment and its mitigation under impulse. This is especially valid when you consider to replace your aging, asset integrate. The last one basically, I think the application of LPS and also high voltage engineering that can also be materialized when it comes to the new development of the components in using new materials and so on that required the testing, the simulations to be carried out, in order to develop the design and the specifications. So, well, that's it. A quick sharing, a brief sharing, when it comes to the high voltage engineering, different perspective, on the possibility effect due to the lightning. So again, thank you very much. Back to you, Dr. Sharma. So sorry for taking some time.
No issue. Thank you so much, Professor Jainal. The questions might be discussed during question and answer session, but it might be quite late for you. Perhaps Professor Chandima will take over the issues. Is it okay, Chandima, if Professor Jainal goes to bed?
I think if there are some burning issues, better take it now for
Okay.
Zainal, uh,
Yeah.
because
Yeah, I'm happy. Yeah, I'm
quite
happy
late for him.
Yeah, if there is any query on what Professor Jainal has presented or the scopes on research activities in the field that is mentioned, participants are requested to put the questions. They can raise the hand or ask the question, unmute themselves and ask the question. Couple of questions we can take.
Otherwise, maybe Zainal can wait a little late.
Yeah, no problem. Yeah, no problem. I can
Okay,
just wait.
Zainal. Thanks a lot.
Well, okay, no problem.
Okay,
All right.
okay. Thank you very much, Professor Jainal. Now it's my pleasure to invite Dr. Anirban Guha, who is a very, very young and energetic member of South Asian Lightning Network, and he represents the Department of Physics, uh, Tripura University, Agartala, India. Somebody is muting me. Uh, okay. Professor Dr. Anirban Guha is the next presenter. He is a faculty member of the Department of Physics, Tripura University, Agartala, India. His main research interests are lightning physics, global electric circuit, and extra low frequency and very low frequency propagation inside the Earth ionosphere waveguide. Now, today's talk that Dr. Guha will be discussing on, or the opportunities he will discuss on, is the research on very low frequency measurement associating with atmospheric activities. May I request Dr. Guha to kindly present or share his presentation? Dr.
Okay.
Guha,
So
you are
is
ready
my
with us?
voice clear now? Can you hear me or see me clearly?
Yes,
Just to
yes.
make sure
Audible
bandwidth
and
is
audible. Yeah, you are.
okay. Okay. Thank you.
It's
So
over to
good
you.
morning. Can I start?
Yeah, go ahead, please.
Okay. So good morning, good afternoon, and also good evening to all of you from all over the world. And I'm very happy and thrilled to be part of this small presentation. I will share my screen, but I have a few slides. Don't worry, I will uh, complete on time. But when I received the invitation from Professor Sharma, I have seen the brochure that it is mainly for the aspiring students who want to pursue their career in this particular field of research. So I thought that instead of going into the research area and other modeling and heavyweight experimental things, I have kept my presentation to the basic level so that whomsoever is interested, they can just be in touch with us and with the group so we can collaborate. So now I'm going to share my screen and would like to have some confirmation if people are able to see my screen, then I will start. So Professor Sharma.
Yes, we can see you.
Okay,
Yeah.
thanks. So I have total 14 slides, but I will go very quickly and I'll not take that much of time. So I know how much time I have, so I'll be able to complete within 12 plus 3. So this is about, this is the our department. A few years back, it was like that. Now it is a bit more changed. Some roads have constructed or something like that. I love this place and I love this place being here and working here. So I invite you all. Last year we had a Salnet meeting in Tripura, RMLT, where Salnet was born actually. So I am very happy whenever you find time, please come to our place and enjoy the beauty. Anyway, so I go to my next slide. So I have created the outline in like that. I will first show you what is very low frequency band and what are the different sources. And I will show some typical examples of experimental VLF data. Very simple. I beg pardon from everyone who knows all about this, but for newcomers, I think some initial things are very important so that they get inspired. So I have given some typical examples and then how it propagates in the Earth ionosphere waveguide and some burning research areas that we have in our hand. So, and then some useful resources. So I think this video is being recorded. So if you can note down, it is fine. You can take screenshots. I will show some websites and other things that you can go and study. And then if you are interested, then we can surely start working. Okay. So in order to do good any research, so now people go to Google, search for papers and other things, etc. But what I believe that going through real good books are very important. In fact, when I started my research, I didn't understand this significance, but much later I understood it. So it's very important. So if you want to pursue your career in particular this research area, I suggest one collection of different books and papers like that. That's what published in 1974, ELF radio propagation. It was a proceedings of the NATO Advanced Study Institute. I have a hard copy and also soft copy of this book. If anyone wants that, I can share that over email or any Google Drive. So it's a very good resource. Maybe in 1960s and 70s, lots of fundamental research were going on that time. So I think before going into real modern publications to understand what is happening in nowadays, it is very important to understand the fundamental things. So if you want that, I can share that book. Coming to the main topic of our presentation now. So we all know that this is the electromagnetic spectrum that extends from, say, very few millihertz to some 10 to the 24, 25 hertz, like cosmic ray. But what we are interested here is only at a narrow band, which we called as very low frequency band, which is in between 3 to 30 kilohertz. In fact, the definition of VLF is, some people like say in this diagram, you can see it is saying that 3 kilohertz is here and VLF is here. But there are ELF, LF, SLF. So there are different bands people defined in a different way. But normally, roughly, we take 3 to 30 kilohertz. And you can understand from this diagram that the wavelength is of the order of 1 kilometer to 30 kilometers. So it's a very high wavelength as far as the radio frequency spectrum is concerned. But we are now particularly interested in that particular radio spectrum band. So now see, there are different kinds of these VLF emissions in our vicinity. Okay, one is natural and one is man-made or artificial, that we should say. So the natural sources of VLF emissions are mainly the global lightning activity. At least 1,000 thunderstorms are active all over the places over the world. 100 to 120 flashes per second occurs anywhere over the globe, and that creates a natural spark in the atmosphere. That actually emits the VLF emission, and mainly for the cloud to ground, that emission is very high because you have a long channel, and from that you have long wavelength. So global lightning activity is one of the main sources of natural VLF emission, which we call as atmospherics or spherics. Then we also have the magnetospheric emission. That means from the magnetosphere, due to charge particle interaction with the magnetic field, there are emission of VLF waves also. And some recent studies, this is a very burning field. If you're interested, you can go into that earthquake. People say there are very good publications that earthquakes can also create VLF emissions from the surface. This is still a controversial, I don't know whether I should say controversial, but it's a challenging field. Many people don't believe, or they don't believe that this is happening. But some data really shows that there are good aspects of this research area. So that's why I have put a question mark here. That is one part. If we come to the man-made side, then we have power line harmonics. Everywhere we have 50 hertz, 60 hertz is harmonic. It is a bad source for us because when it happens, if you don't have a good clean area, then you will not have good reception. So that's a problem for us. This is a noise for us. And submarine communication. So people use VLF for submarine communication. We use the carrier waves, but we cannot decode it, mainly because the skin depth is higher than the microwaves. So in a microwave, it will go for a few centimeters. It can't penetrate the water because of finer skin depth. It's inversely proportional to the conductivity and also the frequency. So if the frequency means go lower and the conductivity, it will penetrate more. So I just want to show you a transmitter, a VLF transmitter, which is located in Japan, that I have taken from internet sources. I've also given the reference. So the height of the transmitter, each mast is around 270 meters. Okay, so you can now understand, in order to emit effectively, a passive antenna requires a lambda by 4 effective emission efficiency. So in order to effectively emit, you need an area which is a few square kilometers. So the people create these kind of VLF transmitters mainly for Navy usage, for using one-way communication with the submarines. But we can use that VLF signal for studying the ionosphere. Okay, so let us see how we can do that. So we can also study the global lightning activity. We can detect lightning also, but we can also use the man-made transmitter for doing that. So there are lots of things that we can do. Before coming to what we can do with the VLF, so here is a typical example of a VLF time series. So I have shown a spike here. So these spikes are lightning spheric. So one lightning stroke or several lightning strokes may be there in one flashes, but the time resolution is not such that we can distinguish different strokes in that particular flash. But if you take the time series and then create the spectrogram, you will see some vertical lines here. Those are basically spherics, the lightning spherics. So these are natural sources. And at the bottom, you see a red line or green line. Those are coming from power line harmonics. And you can see some horizontal line in the spectrogram. Those are coming from fixed frequency transmitters. Okay, and some transmitters are given here. And also you see some periodic horizontal lines. Those comes from the alpha, LoRa. Those were before GPS. Those were used for timing. Okay, so in one spectrogram, we can see many very good features of how we can understand what kind of phenomena is going on in the atmosphere as far as VLF extremes are concerned. A typical diurnal variation of VLF signal we normally receive, we see the sunrise effects, sunset effects. This mainly happens because of the vanishing D region during the nighttime, and then slowly appears, and due to the absorption and the collision of the particles, that creates an absorption. So I'm not going into much detail of these diurnal effects, but from the terminator time shift and the diurnal amplitude and other things, many things can be extracted regarding ionosphere. Okay, so now up to this, I have talked about the ionosphere. Okay, so now let us see how it works actually. Say we have a transmitter, say AM radio transmitter, but consider it is a natural VLF transmitter or a lightning pulse. Okay, so what will happen? It will travel within the Earth ionosphere waveguide mode with a very little attenuation. In fact, the attenuation in transverse magnetic mode is much higher than the extremely low frequency mode that goes in the TEM mode. But here we are considering the TM mode. One advantage is that thousands of kilometers it can travel without such sufficient attenuation, and we can study many things from here. So in this pictorial diagram, which is not to the scale, in the D region is present in the day side, and in the night side the D region is not present. So it can go much higher to the E region, to the ionosphere. And when it comes back, it carries the information of that particular media, though the phase are mixed up there. So we cannot understand how the modes are mixed up. So we have to go to TEM mode to extract the phase information for a particular lightning strike. So in that case, VLF has some limitation. Then we have to go to the ELF. So these are the research areas. So I'm coming to the main parts, or maybe the concluding parts. So I may be having more 2-3 minutes more here. So this diagram shows that what are the research areas that we can concentrate on with use VLF. Okay, so see here you have a transmitter or a receiver. This transmitter can be man-made, or you can consider it as a lightning stroke. So you have the reflection from the ionosphere. Ionosphere can be part of in many ways. Say sun. The sun part of the ionosphere through X-ray, solar proton event, or you have gamma ray, lightning energetic precipitation is there. Sorry. And then you have the electromagnetic pulse from the top of the thundercloud, lightning, Q burst, and the elves, sprites. Those things can also modify the ionospheres. Then also gravity waves and the planetary waves and the tides can also affect. In addition, the earthquake can also affect that. So now you can see the vastness of this study. Just having the data of VLF from multiple stations, you can go to the space weather, you can come to the ionosphere, and you can also study the lithosphere. That is very exciting for me, at least. So that's why these are the different research areas that you can concentrate. Just I have shown one typical example of another spectrogram. But here there is a whistler. We call as slowly the frequency it decreases. It goes like something very high frequency to low frequency within a certain time. And these are whistler phenomena that happens because in the magnetosphere, with the interaction with the charged particles there in the magnetosphere. So this is a typical example of a whistler in a spectrogram. Okay. Now, last but one slide. I have listed here some useful experimental VLF resources. So people who are interested, they can take a snapshot or copy that, or video will be available. But I would like to give some idea. So if I click here, so we have very good links here. So Inspire VLF project from NASA and the VLF Space Weather, Stanford University, spaceweather.com. You have Abelian. Paul Nicholson is there. Abelian, I'm collaborating with him. We are creating a detection network in India. We call Indian Lightning Detection Network. Very good resources are there from that particular area. Then you have University of Florida Ionospheric Research Lab. So if I go there, it's not coming now. Anyway, And then you have the University of Otago, New Zealand. This is Antarctic Radiation Belt Dynamic Deposition Experiment. And this is the website. And this is a very good website. I should say that if someone is interested, they should go by this website. Very useful, very useful. So you can note down all this, you can take a screenshot, and all, of course, the Stanford University VLF group, Star Lab, which is a very good website for the beginners to go through and see the publications and other things. So I think that if you follow these simple resources, you'll be definitely find some interest if you're interested in this field of research, and you'll be happy to collaborate. And if you are interested in computer programming also, so we have access to LWPC. This is the long wave computer capability model from Ferguson. And I have access to this. Professor Colin Price is also present here. I went to Israel under an Indian National Science Program to learn this code. So we have available with us this code and this manual and the book, everything, Fortran course and other thing. Anyone interested in modeling, we can share that. So we are very happy to collaborate. And I don't know whether I have gone very fast or very slow, but here is the end of my presentation. If you have any questions and discussions, so we can, over email, we can discuss, and or if you have questions, we can discuss now. So here I come to my, stop my presentation. I think I stop within time. Thank you very much for your patience. Thank you.
Thank you so much, Dr. Anirban. If you have any queries, I can allow the participants for a minute to raise the question if you have any. Otherwise, we move on to the next speaker.
Okay, I'm here.
Also, yeah. Also, I would like to again remind all the participants who are we have newly joined to put their questions in the chat box so that we can address it during the question and answer session. Now, we move on to the next speaker.
Shri, I think Marcus is going to ask a question.
Yeah, sure. Okay.
No. I don't. No. I think I'm the next speaker, actually.
Sorry.
Yes,
I thought that you're going to ask a question.
Thanks for understanding. No.
So it's I'm very honored to invite Professor Marcus Rubinstein, who happened to be my PhD opponent. I'm very pleased to have you here, Professor Marcus. Marcus Rubinstein attended graduate school at the University of Florida, where his PhD work dealt with the coupling of lightning electromagnetic fields to overhead lines. He is currently a professor and head of the Advanced Communication System Group at the University of Applied Sciences and Arts, Western Switzerland. His current research work is focused on different aspects of lightning measurements and modeling, as well as on the location of radiation sources using electromagnetic time reversal. So I would like to invite Professor Marcus to talk about tall objects, rocket and wire and lasers in lightning research. Professor Marcus, it's over to you.
Thank you. Thank you very much for the kind introduction. Hello, everybody. Can you see the slide, just to make sure?
Yes.
Yeah,
Okay, great. Okay, so let me go right straight, because there's not a lot of time. I'm going to go straight to the outline of the presentation. So there will be 4 points. So the first one is, how can lightning be studied? And this refers to the fact that it is random and you don't really know when or where it's going to strike. Then I will go to the 3 points that appear in the title, the use of tall objects, rocket and wire, artificial lightning, and lasers in also artificial lightning initiation. So the first point is then how can lightning be studied? And I'm going to list here different ways. I mean, the first one is instrumented tall grounded objects that can be used, because we know that they are struck by lightning sometimes several times a year, or sometimes several tens of times a year. So you can instrument them and make measurements on them. Then another way to study lightning, of course, even if you don't know, when or where it's going to strike, is if you can initiate it artificially, you will know then when and where, because you're initiating it where you want and at the time that you want. And then lastly, of course, there are remote measurements that can be made. These measurements are actually, so these first two are direct measurements, and then the last is indirect measurements. And what I'm going to do is I'm going to have only one slide on the remote indirect measurements, because it's not really the main topic of the presentation. So the next slide will be on that. And that would be then this one here, where I'm showing actually that if you are far away from lightning, then you can, let's say I was going to say sit someplace. I mean, sit inside, hopefully, and then you can measure here. If you are close enough, you can use cameras, for example, to do optical measurements, and then you can also have antennas of different types to measure the radiation. These work, of course, also if you are so far from the lightning that you can't really see the lightning, and that you can still use the radiation from the lightning to infer properties of the phenomenon. Now, let's go right now to the direct types of measurements, tall objects. So to make measurements using tall objects, and we know that tall objects are struck by lightning more than, like, say, flat ground, for example. So you wouldn't want to have sensors placed someplace on flat ground, because you would have to wait forever to get measurements from direct light current, for example. So you could use, for example, a tall tree. And this is not a good idea. This is just for illustration purposes, since the tree will actually be maybe set on fire or something. But you could use some kind of sensor, like a Rogowski coil or some other type of sensor, to measure, for example, the current. And if you have a lightning, then you would be able to make a measurement that way. Now, of course, in practice, this is not really the way this is done. And what happens is that what we use is actually tall grounded objects like the ones that are shown here on the screen. Now, there's, of course, also other tall objects that are used. For example, just buildings that have been used in the past in, let's say, in the 1930s in New York. For example, the Empire State Building was used to make current measurements. And nowadays there are measurements made also in Brazil, for example, in Sao Paulo, mostly optical measurements. But there's also wind turbines that can be used. They're used in Japan. But what I'm showing here is some towers that have been instrumented for the measurement of direct lightning currents and other types of measurements. And the interesting thing here, let's say, is that we have then they're organized by size. So you have the 25-meter tall eagle nest, this the smallest one, going all the way up to the 634 Skytree tower in Tokyo. And so we have the Morro do Cachimbo here, the 60 meters tall in Brazil. We have the Geisberg Tower, or Geisberg Tower in Austria, and the Sentis Tower in Switzerland, the Peisenberg Tower in Germany, the CN Tower in Toronto in Canada, and then the last one, like I said, the Skytree Tower. So I'm going to say just a few words about the way these things are used, and basically I'm going to say a few words more about this tower for two reasons. Because this tower in the middle, on the one hand, it's in Switzerland, that's where I live, and on the other hand, it has a very high incidence compared to other towers. So this is the tower, which was the Sentis Tower, which was instrumented 10 years ago. And it has really a very high incidence, but the highest incidence, more than 100 times a year, it is struck by lightning, mostly by upward lightning. And that is consistent for many years, which is much higher than other towers. So let me show you now, I'm going to show you what you would expect if you would measure the current when you have a lightning that strikes this tower. And because this is struck by lightning, mostly upward lightning, I'm going to show you then the upward lightning. And this is actually for upward lightning, not only to this tower, but it's similar to all other towers when you have upward lightning from them, and specifically negative upward lightning. This thing that looks like a bat here is actually represents the tower, and that's the cloud. I'm going to come to this later, but I'm going to show you here on the right there is a plot of what you would expect to see. I'm not going to go through all the details. I'm going to mention everything here, but I'm not going to really go into all the details to try to remember everything, just to show you that we can learn a lot from these measurements and from the towers. And by the way, most of the data, most of the current data that are used for lightning protection nowadays, it comes from actually tower measurements that were made by Berger last century, Professor Berger in southern Switzerland. But the current here that what you would see actually for this type of lightning is a slow current. This is marked with a dashed line here. So it's like a slow current that can last for tens or hundreds of milliseconds, and that has pulses superimposed on it. So this current is called the initial continuous current, ICC, and it has ICC pulses on it. Sometimes lightning, the upper lightning stops here, but sometimes it just continues. I mean, the current stops, but then it is followed by a big pulse that you would measure on the tower coming from a return stroke, which may or may not be followed by some other current similar to the ICC, but this time called CC, continuing current instead of continuous current. So it is a continuing current, which may also have pulses. And then there are many of these pulses you can have actually after this initial stage here. So let me show you on the left now graphically. So you have the whole thing starts upward and in branches. At some point you have then the branches disappear, and then you have this current here with some pulses. Then the current stops, and then you have some discharge that comes from the top, a liter, that is followed by a discharge going up, which is that pulse that you see here. And this, as I said, repeats many times. I said that very quickly, and the idea is not really to memorize everything, but just to know that there are many, these are complex phenomena that have different processes, and that you can learn a lot from just measuring the current, and also, of course, measuring other things around it, like optical measurements and fields and X-rays, etc. So the times, just to see here, I just have scales here in milliseconds, and here is like hundreds of microseconds, and then amplitudes that are of the order of tens of kiloamps sometimes, or kiloamps, or some of these pulses are actually a few hundred amps, or the this continuing current. So let me show you now. I'm going to show you a video of one such flash, lightning flash. So this is actually taken from that same tower, the Sentis tower. It's a high-speed video. This one is not exactly the same because it's a positive. I showed you a negative before. There are differences, but this is a positive. You can see also that it is complex and it branches a lot, etc. So this is just an illustration. So I'm like everything I'm giving you here, I'm not going into the details of anything because of lack of time. But the thing, this is going to go now in reverse. So it's coming back in reverse. I'm just going to skip to the next slide in the interest of time, and go to the next method. I mean, instead of tall objects where you have to wait for the lightning to happen, you can also produce your own lightning by using this rocket and wire technique, or also called triggered lightning or rocket initiated lightning. And the idea would be to do something like this. I mean, if you were like strong enough, you could maybe throw a spear in the air attached to the ground with a cable, and you could produce lightning. This is a kind of a dangerous way of doing it, so better not do it this way. The way it really is done is like this. So you have rocket trigger lightning. This is in Florida, and you have here on the right rockets. These are the small rockets that are used in this launcher. And when the fields at the ground are high enough, of the order of a few kilovolts per meter, sometimes 10 kilovolts per meter, site dependent, then you can launch the rockets, and as they go to heights of maybe 200 to 300 meters, then you get lightning striking basically the rocket and the wire that is, because I didn't mention that they have a spool here with conductive wire that is connected to the ground. The wire unspools as the rocket goes up. So let me show you now a video in Camp Landing of this. So what you heard, I don't know if you heard it, but if you heard it, these are scientists who are very excited about the fact that they managed to get some data, because sometimes you have to wait a long time for the conditions to be the right conditions. So that was an example of triggered lightning, and the wire vaporizes instantaneously. It's really interesting actually to see. So let me go now to the next and the last part. I'm not sure if I'm doing this too slow or too fast. No, I think it's 12 minutes already. So let me go very quickly to lasers in lightning research. So for this, I'm going to just say that in the 70s, there was already there were experiments actually in the lab for very short discharges. And in the 90s, an interesting experiment, this is the only one I'm going to mention here, by Uchida et al., which was published in 1999. They used a tower, a laser, and a field sensor, and a field sensor and a mirror here. So that's the tower, that's the cloud. If you concentrate on the cloud now, you will see the first thing that happens. So what they did was a clever thing. So there is something called a preliminary breakdown. This is a discharge that happens within the cloud before a lightning. And they detected this because it radiates, and they used this field sensor to detect when the lightning started. Basically, there was some activity in the cloud already. And at that time, they measured the fields, they identified this as preliminary breakdown fields or pulses, and then they communicated that to the laser to activate the laser. And once the laser was activated, then lightning happened basically twice. But it's not clear, really, it's not conclusive that lightning was actually triggered this way, because it could have been a coincidence, because this was done many times and only on 2 occasions did they have actually a lightning that happened. So since there was already this initial activity here, perhaps the lightning was going to strike anyways. And here, this part of the laser that was actually here, the ionized column here, was actually very short in their case. So it's not sure. Maybe they did, maybe they didn't. But in any case, nowadays, just to finish, I'm going to say that there is one more project which is financed by the European Commission, which is called Laser Lightning Rod, and it uses a high power, high repetition rate laser. We were going to use this actually already this past summer to test it already, because it has been built, the laser, but the COVID situation actually made us cancel this experiment. I will show you the laser here. So the laser is here. Some information on the laser is here about, I'm not going to read it. And I think with this, let me see if I'm coming to the end. This is just the laser is pretty heavy. I mean, it's like a 2-ton thing. It's going to be taken up here by to the tower by helicopter, and then I will just finish with the picture of the tower again. And thank you for your attention. If you have any questions, please ask the question. I will be happy to try to answer them at the end.
Thank you so much, Professor Marcos. One question I have seen on the chat box is that, as I have heard, this is from Nasif Karta, as I have heard, rocket trigger lightning are similar to subsequent stroke of natural lightning events. Is there any way to emulate first stroke artificially? If not, what are the challenges?
Yeah, that is a very good question. Indeed, when you do when you use trigger lightning, yeah, you get only little return stroke sequences that are similar to subsequent lightning and not to first lightning. So in any case, I mean, for using triggered lightning, I mean, one thing that it has been done is, for example, to use just instead of using conductive cables, you can leave a big gap with a cable that is not conductive, but then you don't have the guarantee that it's going to strike the location where you have your sensor. So and it is not necessarily all the same type of lightning either. So there is basically at this time I would not be able to answer the question, but I could suggest actually that this be a subject of research, and just to see how you could try to trigger first return strokes in really natural lightning. Because we don't have, this is one of the disadvantages. I had a table actually that I didn't show because I didn't have the time, and which gave that as a disadvantage of this type of artificial lightning. There's a lot of things we don't know about because there's not much measurements on direct measurements in any case on first strokes.
Yeah, thank you so much, Professor Marcos. It was very nice to have you in the program. Now, before I move on to the next presentation or next presenter, I would like to just request Professor Earl Williams, if I am correct. I have seen him somewhere. Earl Williams, are you there? Can we say hello to you? Professor Earl Williams. Okay, I can see Amitabh Nag as well. Dr. Amitabh Nag, are you around?
Yes, I am. Hi, Dr. Sharma.
Yeah, hello.
Hi.
Good to see you here.
Yeah, good evening or good
Good
morning. Yeah.
evening. So, can you show
Yes,
up?
I'm here also. This is Earl Williams.
Okay. Can we see you? Please just say hi to everyone.
Let's see. How's that?
Oh, wonderful. We saw you in Tripura as well last year.
Okay. Very good.
Yeah.
Ah, great. Namaste.
Okay, and now next presenter is Mrs. Foster Lubasi from Zambia. She is the director for the Zambian Center for Lightning Information and Research, JASLIR. Before establishing the Lightning Center, she worked for the National Institute of Scientific and Industrial Research as a technical officer and later as a scientific officer. Her work of 25 years in the institute mainly involved lightning protection for scientific equipment. Today she will be talking about the challenges in research and development in Africa. Mrs. Lubasi is a very active member and the co-host or co-organizer of this program. Mrs. Foster, it's
Hello.
over to you.
Okay, thank you so much. So I will share, then I will open. Can you see? Can you see my presentation?
Yes,
Yes. Go ahead, please.
Okay. Yes. Thank you so much for giving me this opportunity to talk about the challenges of R&D in Africa. The investigations that I'm going to share was done by the Zambian Center for Lightning Information and Research. I have a few colleagues who were able to do a bit of research with me when I was asked to share, and those are my names, like it has been said. I'll say that when I was asked to talk about the challenges of R&D in Africa, I was very happy because I thought it was a very simple subject until we decided to consult a few scientists and engineers, not only in Zambia, but from the neighboring countries. And then I realized how complicated the subject was. And I sincerely hope that this summary will shed some light. Also, given the time constraint, I have to make sure that I do it within 12 minutes. So I'll go straight into the challenges. I say that the challenges Africa has, the major ones really is what was coming out most prominently is that it does look like we have a lack of understanding of what R&D is and its importance or the role that it plays in social and economic development. And therefore, you find that in most African countries, R&D is not categorized as a priority area. We also did notice that most of Africa still suffers from the effects of colonialism in a big way, I should say, because it came out quite prominently. Find that most Africans are still mentally and physically colonized. It's been seen by the fact that most R&D in Africa is usually dependent on externally driven agendas. Also, Africa is still experiencing quite some huge influence from former colonizers, almost like Africa is not really running its own affairs and not determining what it ought to be, what it ought to do. We also recognize the serious problem of political interference in R&D. It's not uncommon in African countries to have somebody who knows nothing about science and technology leading such institutions, and that is usually affects us very negatively. We also recognize that there is no linkage between research and industry. I saw when Professor Zainal was presenting, I'm almost turning pink with envy when he says, no, you have the industry and the industry brings their problems and you need to solve those problems. You don't have anything like that in Africa. There's no private sector participation. And therefore, we find that R&D is mainly dependent on government funding. And as it is well known, most African countries, the economy is not doing so well. So to depend on that funding, you can't really get to do much. And we have very limited community engagement in research. And also technological backwardness, like we have, internet services that are very slow and very expensive. And so it's not affordable for most people, for an average African. Like most people would like to attend these webinars, but they probably don't have a suitable computer and stuff like that. You notice that the other problems that are going to come up are really offshoots of the major problems. See, when you have inadequate or lack of science facilities in schools, it's because research is not a priority area in Africa. It's it's very common in African countries to find schools that don't even have laboratories at all. And if they do, they're very poorly equipped. And then also sciences are generally perceived as very tough subjects and therefore usually shunned by most students, especially females. We have programs there for motivation of the children so they can at least take part in the sciences. We also have a problem of limited exposure to R&D and technology at an early stage of life. Even just to technology, exposure to technology, you find that somebody who gets to know about computers when they may be in university or some even in the workplaces, those born before computers, like we say, born before the 90s, who are the current crop of scientists. So that lack of exposure in the early stages to technology, I think does affect the way we do our research. There's also the lack of modern research infrastructure suitable for R&D. Again, it's because of the priority just placed on R&D. It's not so high, so we have lack of modern research infrastructure in colleges, universities, and even in research institutes. We have lack of appropriate research equipment and basic equipment like suitable computers. I worked in a research institute for 25 years and well, it's a long story. We have lack of key services like is mentioned earlier, such as fast and reliable internet, and also in subscriptions to relevant websites for scientific information. We have lack of mentorship. I think most of the time you're on your own. Really, you get to college, you get out of the university, you're pushed into this working world. You get a job maybe with the government, and you literally on your own. And half the time you don't even know what to do and where to go and stuff like that. Yeah, I would like to appreciate. This is where I really appreciate coming into this onto this stage of the lightning researchers from Kathmandu, a very special place for me. Met Professor Gomes, met Professor Mary Ann, met Dr. Sharma, and since then I think I've learned a lot than I have in all the 25 years. So that's quite a challenge. We lack mentorship. We have limited exposure for students, even just programs like student exchange programs, or even industrial visits. And I deliberated by the right people, because it's not uncommon to have an industrial visit to maybe a developed country, and you have the wrong people going there, and therefore the trips don't yield much results. Therefore, we have a shortage. We also have a shortage of qualified personnel, such that because of the lack of proper planning and proper categorizing of science, we really have a critical shortage of personnel in most fields to form research teams. You find one or two people there and one or two people in this and the other field, and we are unable to really form formidable research teams that can produce tangible results. And also the culture of teamwork, not very well developed out here in Africa. It was noticed most people would rather work as individuals than as teams. But it was also noticed, I don't know about other countries, that in Africa, there's lack of incentives for being a scientist. In fact, the government budgets for research is very low. As a result, most projects remain unfunded. If you find a project running, then it's most likely running effectively. It's most likely funded from outside. And therefore, it's not locally, concepted. And also, it's said that it's better paying and more respectable to be in management and social work than to be in research. And therefore, this discourages people from, and therefore, hello?
Yeah, we can hear you. No issue.
You can hear me? Okay, great. Okay. I'm about to finish. This is human factor. I hope I haven't exceeded by 10 minutes. We also have the issue of the human factor, where you have misuse of resources made for research. In most that came out was that especially finances and research vehicles and time, because people spend time doing their own things instead of doing research. We have the negative influence from former colonizers who are normally assisted by local people, that is Africans. You see, Africa is terribly rich in natural resources and can have a good life if it is well managed. But it has a huge challenge to navigate its way out of the grip of former colonizers and other external forces and self-destructive tendencies. I was able to quote this Zambian Mukula timber worth $3 million, which was confiscated in Malaysia, because this was in the paper all over the world, in the papers all over the world on 4th March. So this is how I think sometimes our own tendencies tend to hinder important things from happening, because we misuse the resources and stuff like that. And sometimes we place the resources where it doesn't even matter most. However, it's not all very sad news. The good news is, like this forum given to me, we're beginning to talk about these issues almost on every forum. I do recognize that it will be a long and tough battle, but it has at least started because we get to hear a lot of people actually talking about these things and how Africa needs to rediscover itself, and how we can, be a better country and develop actually because of how rich we are in natural resources. So I can only say that just like the ending of any detrimental world systems, Africa will need the support of all well-meaning citizens of the earth like yourselves to get to a place of normalcy. Because I truly think the way things go in Africa is really not normal. And unless we can get onto that place where we begin to run our affairs normally, we still have a long way to go. But we have started, and I'm sure with the help of people like yourselves, we can get somewhere. So thank you so much for the time. and for listening. That's the end of my presentation. Thank you,
Okay.
Shama. Are you there?
Yeah. Thank you, Foster. There is a question from Professor Colin Price.
Okay.
Professor Colin, can you ask the question by yourself?
Yes, Professor Price. I'm all
Yes.
ears.
You can hear me?
Yes, I can.
I'm asking, well, with all the problems you've presented, how can
Yes.
we, the scientists from non-African countries, help in promoting the R&D in Africa? Maybe often when there are problems, there are also opportunities. So maybe you can tell us how we can help.
Actually, that's a good question, Prof. I hope can people see me? Can you hear me?
Yes, we
Yes.
can see and hear you. You can unshare your screen if you wish.
Yes.
Yes. Actually, there's a lot of ways actually that you people can help, like the exposure that the Lightning fraternity, or is it platform, is giving me. The exposure, mentorship. Last year, I think we had Professor Nile from Egypt, although it's also Africa. But I think through Arconet, he did help supervise a student, and I hope Bruno is on this webinar, because I did ask him to join us so that he can continue his collaboration with Professor Nile. So I think mentorship and just ideas. You read through those. Challenges, and probably I think we can collaborate, consulting where we are at, what are we doing, and also just sharing your stories with us, because I don't know where you people started from and how did you get to where you are. I think when we get all those stories and we put all those things together, we surely should be able to find our way up the ladder, if I may put it that way.
Yeah.
Okay, thank you.
Thank you, Foster, for the nice presentation. And of course, we share our problems with you too. And now, before I move on to next presenter, I would like to say hello to Professor Marcelo Saba and Dr. Fernando Miranda from Brazil, both of you from Brazil. So can we say hello to you, Marcelo and Fernando Miranda? You can unmute and say hello.
Do you see me?
Yes, now.
Okay, nice to be here with you.
Yes.
Oh, my presentation is going to be tomorrow. I'm joining it already.
Yeah. We want to welcome you in advance.
Thank you so much.
Yeah. Dr. Fernando, are you there? From Brazil? No. Are you there? Okay. Okay, let me invite next presenter, Mr. Ron Holle. Ron Holle is a meteorologist in Arizona in the United States, with an emphasis on lightning safety, lightning detection, and uses of lightning data. Ron worked with NOAA research laboratories prior to joining Vaisala in Tucson in 2000, and is on the executive committee of the African Center for Lightning and Electromagnetics Network. He has authored and co-authored 77 journal papers, 18 books and book chapters, and 338 informal papers. Many are related to lightning safety and electromagnetics. Ron has spoken about lightning safety and other lightning topics in the US and 17 other countries. He was elected as a fellow of the American Meteorological Society in 2009. So we invite Mr. Ron to talk about lightning occurrence and casualty statistics at the regional and global scales. The right person in right place. Mr. Ron, you are welcome to present your presentation. It's over to you now. Yeah, Ron,
There we go. All right.
Yeah, now it's okay.
Okay, you see my screen?
Yes, we do.
All right. Thank you very much, Ram, for inviting me and to this very impressive group of people and impressive group of topics. I'm going to talk about two topics today. So just broad categories of lightning occurrence, and the other one is lightning casualties. So let's talk about lightning occurrence first. Vaisala owns and operates the global lightning dataset GLD 360 and has been running this for some years now. This is a map of the last 5 years, 2015 through 2019. Approximately 10.5 billion events are detected, and it is a global network that covers everywhere. There is a nice short article that referred to in Weather Magazine a couple of years ago. You can see there's maxima over land masses all around the world, and also along mountains, islands, and coastlines. And there's just a lot of information here. I feel very privileged to be able to work with the data on an ongoing basis. This is a global network. Here in Arizona, it's quite a large state. It's 700 by 700 kilometers. And when you start to look down at detail on a 2-mile grid, in this case, you can see that even on a small scale, there's a lot of variability. We have a lot of mountains here, and the slopes are very important for producing lightning. Another thing we can do, this is from the U.S. National Lightning Detection Network. These are cloud-to-ground flashes. You can see that there's typically has been 400 to 500 or more thousand cloud-to-ground flashes every year. But in the last 2 years, we've had a dramatic drop, and this year was incredible. It was 30% of the normal amount of lightning, and we had a very dry year. We had a high-pressure ridge across the top of us. The monsoon essentially failed, so a big surprise, but it happens. So the GLD 360 detects 100% of the thunderstorms around the world, and next week on the 8th, we will become operational with the version 4.0 that has a 1 kilometer location accuracy on the average, and it correctly classifies cloud-to-ground strokes versus in-cloud lightning 85% of the time. And the range of these sensors is about 10,000 kilometers. So the sum of the cloud-to-ground plus the in-cloud is called total lightning. So a number of uses have come up over the years. I've watched the National Weather Service use the lightning data, and it's often combined with other data sets. And as a meteorologist, we generally try to combine it with everything we have. Here are some situations where I've seen them use it. When's the first flash, so that they know something has begun that's a significant storm? Is it a shower or a thunderstorm? What orientation and size and shape does it have? Is it very excessive, such as it is a danger for many reasons? As a meteorologist, radars often have a cone of silence around them, but lightning data doesn't have any such things. And you can also look at lightning within stratiform areas, whether it's isolated or organized. You can find whether it's a cold low aloft, heavy rainfall, and the last flash is also very important for a lot of purposes. So this is just a small sample of a lot of things that lighting data are used for. During 2020, there were 2 events in Uganda that we've looked at as part of ACLE-NET. Unfortunately, there were 4 mountain gorillas that were killed back in February. It's a very limited number of them left. This is a Rwanda, Uganda border down through the middle, and you can see that there was a fair amount of lightning, but not an excessive amount. Then unfortunately, a few weeks ago in northwestern Uganda around Arua, there was an event that where unfortunately 10 boys were killed while they were playing football. And this is more of a 3-hour period. And you can see there was a fair amount of lightning around, but it is isolated. And this is a perception issue about whether it's overhead or not. So I'll finish up the lightning data section here. I said, if you're interested in lightning data, I can provide historical data to a university researcher at no cost. The conditions are provide an abstract, and we want to approve the abstract that it's a significant or substantial research project, and up to 1 million square kilometers, up to 5 years, and no intercomparison of other detection systems without our participation, because it is much more complicated than simply making counts. So anyway, there's my email. I'll show it again later. Sort of things you could do are meteorological case studies like I just showed, or you could do climatologies like I showed for the world in Arizona. You could relate it to other data sets like damages to utilities, human casualties, volcanic lightning, it's a big topic, and geophysics, as we've seen earlier, some talks today. Now I want to go into the lightning casualty part of my studies. I published this paper over here on the right. This is a summary of national scale lightning casualty studies, fatality studies, and the rates are in fatalities per million per year. And as you can see, all of the rates over 5 on a national basis over multiple years is in Africa, but there are other areas with in-between rates. But unfortunately, you see a lot of white shaded countries here that we don't have data for. So very briefly, lightning safety is certain if you're inside of a large, substantial, frequently occupied building or inside of a fully enclosed metal top vehicle. It's not certain safety what you're wearing or carrying or how you stand or where you stand or what you're standing on, essentially anywhere outside. This is a fundamental issue with lightning safety that sometimes is missed. So more of a fun thing, we put out a little booklet called So You Think You Know Lightning. You can just Google that and you'll find a more of an educational, fun thing for the public. And it might be helpful for your students to look at that. I'll show it again later. So the number of reports of lightning casualties in developing countries are increasing, the reports, because there's better internet penetration, so there's improved reporting. I think this is underestimated. I think it's very important. There's also an increasing number of people in developing countries, and much of this population is involved in labor-intensive agriculture, and they have no lightning-safe buildings or vehicles. And for much of this population, lightning awareness is not up to where we'd like it to be. The detection systems are not available, warnings are not available, the medical care is not very good. So for example, we have a paper coming up in the American Meteorological Society annual meeting next month, and I've been looking at school events from the mainstream media, doing Google searches, and there were 43 schools that were hit with 94 deaths and 554 injuries. So this is one of the main categories that's causing lightning casualties in Uganda, and I'm sure in many other countries. So my estimate is that there are 24,000 people killed and 240,000 injured around the world. That the rate and the number are going down in developed nations, but they're actually increasing in developing nations. Much of this has to be looked at very carefully because it is a reporting issue rather than an actual issue, but it is going up. So we have no data for many nations. We need studies in many developing nations. And a lot of the reports or the studies are 10 to 15 years old. And I think there's been such a great improvement in news gathering that we probably should do these again. So you could use online and print news sources, national medical records, Met service data, personal data collection from sources, natural hazards databases or other things. So I'd be glad to work with you, first of all, on the global lightning data set GLD 360 on that policy that we have, and also casualty studies in developing nations. Contact me or Dr. Cooper, who is speaking right after me. And here's a few websites on lightning safety, ACLE.net. Dr. Cooper will be talking about shortly. We have a U.S. group called the National Lightning Safety Council that is at this site. And again, here's this lightning education booklet. Thank you. That's all I have.
Thank you, Ron. I think there are some queries, but these are some kind of suggestion and sharing with you. Mrs. Foster, I think you have a couple of queries or questions to Ron.
Yes, I have one.
Okay.
Can I ask?
Yes, go ahead.
Sure. Sure.
Okay,
Go ahead, Foster.
to what extent can you provide data over a country? Like, for instance, are you able to provide the lightning data for every area? Like in Zambia, like for Lusaka, for Ndola, for different towns and like a specific area. Are you able to do that?
The GLD 360 network is global. It covers everywhere. Yeah, we prefer not to provide little snippets of information for specific events and specific times. We'd rather provide it in a larger, organized fashion. We're not well set up for short, specific requests. But if you have a project where you have specific areas within a larger context, we'd be happy to supply the data.
You can? For a specific project, you can?
Yes. Yes.
Oh, great. Thank you.
Need to provide an abstract, and essentially like you would do for an abstract for a conference. We'd like to look at it as a robust scientific project rather than a specific curiosity. Let's put it that way.
Okay. Thanks.
Thank you. Good to talk to you again, Foster.
Thank
Yeah,
you.
thank you so much, Ron and Foster. Yes, we'll talk to Ron over and over again, because he has been helping us to provide the data and doing collaborative work on faculties. Thank you, Ron, for the wonderful presentation. Now I move on to next presenter, Professor Marianne Cooper, the most energetic and dedicated lady in the team, and she is the co-host host of this program, and she represents the chairman or director of African Center for Lightning Electromagnetics Network. And here is her profile. Marianne Cooper, MD, an emergency physician by training, is an international expert in lightning injuries and lightning injury prevention. She received her BS and MD from Michigan State University and trained in emergency medicine at the University of Cincinnati. In addition to awards from both the medical and lightning communities, Dr. Cooper was the first physician to be awarded fellowship from the American Meteorological Society in 2003. In 2014, she was awarded the International Conference on Lightning Protection Scientific Committees Award for Outstanding Contribution to Lightning Science by research or teaching. She has served as a board member of the Lightning and Electrical Shock Survivors International Support Group for Lightning Survivors over 30 years. Dr. Cooper was awarded Professor Emerita on retirement from the University of Illinois, where she also held appointments in neurology and bioengineering. She continues working internationally to mentor young lightning scientists, research and prevent lightning injuries, and educate and raise awareness of lightning safety. Since 2014, she has been the Managing Director of the African Center for Lightning and Electromagnetics Network, a non-profit dedicated to reducing deaths, injuries, and property damage from lightning across Africa, and is active internationally with many other lightning safety programs around the world. Yes, of course, Professor Cooper has been working with us with the South Asian Lightning Network very actively, and this is her efforts that brings all the scientists in this community today in the single platform. I would like to invite Professor Marianne to talk about medical and lightning injury prevention research questions. Professor Cooper, it's over to you.
Thank you. And it's a pleasure to be here. Thank you to all the faculty who are participating. And can you see my screen too? Let's see.
Yes, yes.
There we go. There we go. Okay. Well, very good. I thank Ron for setting up my talk so well because he covered a lot of what we're doing in Africa already he's on the executive board for and the board of directors for ACLE-NET. And originally my topic was supposed to be medical questions and protection in the developing world. But there's a lot of people who are covering protection, and Foster and Ron are covering the developing world. Francisco is covering protection of small structures. So actually, I changed my talk around to medical and lightning injury prevention. Now, you all may call it safety. I call it injury prevention from my aspect as an emergency doc. I learned a long time ago that it's a whole lot better to prevent injuries or illnesses, either one, than it is to treat them afterwards. So I'm really going to be talking from the physiology and medical aspects, not from Africa, not from so much safety. So I hope that maybe we've got some physiology people here, because as Chandima pointed out to me a couple of days ago, what are we going to do when Chris Andrews and I retire? So we're trying to raise up our own successors, and we'll be happy to work with anyone. Input for this talk was solicited from Chris Andrews in Australia, Ryan Blumenthal in South Africa, Norberto Navarrete-Aldana, who has worked with Ron and I extensively on doing studies in Colombia. He's on the call. Hi Norberto. I'm glad to have you here. Bill Roeder from the USA Lightning Safety Team, and Katie Walsh-Flanagan, also from the Lightning Safety Team in the US. One of the things that Ron and I did a couple of years ago was we basically dumped our brain into a book. This book is available if you want to pay for it at Amazon or Springer, but Ron and I don't get any royalties on it. We don't make any money if you buy it, and I just posted it all on ResearchGate, so under my profile there, you can get it all free. We've had up to over 500 readings of just the lightning protection chapter. I'm not a lightning protection specialist, you all know that. But Chandima helped me a lot with that chapter, and I appreciate that. There are chapters in the book. It's written for basically this kind of audience, undergraduate, graduate students who are looking for projects. Each chapter is only an overview. You all are so much more knowledgeable in this, and many of you have written extensive textbooks and wonderful publications. This is only meant as an introduction. And so it discusses sort of the current state of where some of the research is, both from the medical, from the physiology, from the population studies like Ron does, from lightning protection, from how to build a safety network and do education, particularly in developing countries. And it's got subsets like this, where it's research question. What are the things that still need to be answered? Does the data that is out there, does it apply to your country? Does it need to be updated? As Ron said, many of these studies haven't been done in 10 or 20 years. Talk about the mechanisms of lightning injury. Most people think that direct strike that's all they think about for lightning. Now, you all are more sophisticated than that. You know more about ground current and side flashes and upward leaders and those kinds of things. This is numbers that Chris Andrews, Ron, and I came up with around in 2008 about mechanisms of injury. But is this distribution the same in the developing world? This is what we came up with from reading hundreds, thousands of news reports in developed world. Now that we're starting to get a lot of reports in the developing world, what actually is the distribution of mechanisms there? In developed countries, we know that at least 90% survive, but may have permanent damage and permanent disability. Does that apply in the developing world as well? At this point in the developing world, we're really only paying attention to deaths. And that's what's documented in the newspaper reports. Injuries are seldom injured or seldom discussed. They may not be documented very well, and people aren't paying a lot of attention to it. But I can tell you that injury to someone who survives with the brain injury afterwards, with the chronic pain problems, because this lightning is a neurological injury. It damages the nervous system. These can be devastating not only to the individual, but also the family. So at some point, we'll get advanced enough and far enough along with our lightning safety work in developing countries that we can start addressing the injured as well as the dead. Okay. One of the misconceptions I find particularly with physicians, but also with just about any other kind of engineer, or particularly electrical engineers who think they know electricity. Again, you guys, all this faculty, all of the students that are attending, you are a subset. You know lightning is different, but most electrical engineers have no training in lightning. And so they start thinking, well, I know about electricity, and either professionally or just from plugging in my computer. And so if I know this is what electricity does at that level, then it must be so much huger, so much bigger as to what the physical effects are. Well, I'll tell you, lightning injury is not scalable. You can't say, well, I have this with 110, so I must have this with 12,600 kilovolts or 12,600 volts for an electric line, or with 10 million volts for lightning. It's not scalable. Now, the X is here to remind me to say that the next 3 or 4 slides are slides that I put together for physicians. They may not be the way you all engineers and experts and physicists would present this information, but it was meant to communicate what lightning injury is to physician groups. I was asked to speak to a rehab institute, major rehab institute here in Chicago a month or so ago. And so I put it together for them, and it explains it, hopefully in a simple enough way that physicians can appreciate it, and you won't judge me too much. So with electrical injury, most physicians are familiar with high voltage electrical injury. But the differences between electrical injury and lightning injury, first of all, electrical current is fairly, you grab onto a line and you get a constant exposure with consistent injury, long exposure. With lightning, it's almost instantaneous. Okay. Martin Newman has a great chapter in his very old book, but it's still wonderful, that talks about how much lightning energy actually gets to the ground. And most of it is dissipated in light, heat, and all kinds of other types of energy, so that he estimated that probably only 1 to 10% reaches the ground. In addition, if you've got ground current, it's going through the ground before it gets to you. And so there's really not a lot of energy that gets to the person. One of the analogies that a friend and I use is if you had a bucket of water and you were trying to pour it through a straw, how much energy would actually go through, how much water would go through that straw? That's about what we're talking about with lightning injury. Okay, so if you want to take a look at the dose, if you will, and that's what I'm talking to physicians about, then if you take the typical electrical contact and multiply it out by about the time, that would give you a dose, if you will. Well, if you look at lightning, even though you've got a huge amount of energy, you've got a very tiny number of seconds or microseconds that you're exposed to it. Now you can play around with the number of seconds and the number of volts and everything else, but you still get the idea that you're talking about tens of thousands of exposure of doses, if you will, compared to tens of doses with lightning. Well, one of the implications of this is that it takes a lot less energy to cause functional damage, such as the information that what we get with cardiac arrhythmias and neuropsych problems than it does to cause the major physical burns. Lightning usually causes a lot of functional but very little physical damage. It's a neurologic injury, as I said. It causes brain injury and it causes nerve injury with chronic pain syndromes afterwards. It's not a burn injury in general. However, it is more of a burn injury in the developing world. You can contact me about that. We need more information about how current passes through the body. We need finer detail than has been modeled in the past. Consideration of multiple pathways, not just one. We need this at the organ level, and we need finite analysis. Finite element analysis is what Chris calls it. I don't know about that. What parts of the brain are injured? There's some great work being done now on concussions and about what happens with the energy, even if it doesn't seem to have gone through the brain. What are the effects of the concussive injury or being thrown versus the electrical effects? Because we have both in the lightning victim. And how do we intervene in the injury cascade? Once it's set, once it's happened, is there a way to intervene and keep it from everything from falling apart like we see with the lightning survivors? What are the long-term problems? Does this get better or worse? Does the lightning injury affect the lifespan or predispose to other illnesses, such as, we know it affects blood pressure, but how about cancer, Parkinson's, and so many other syndromes? As far as safety, how far can one hear thunder? We need to take a look at that and re-examine the interstrike differences for different parts of the world. What are the precursors to lightning that could be useful? Are there other precursors besides just thunder that we could use? Developing a fatality risk map. This has been modeled before with Ashley and Gilson. Siakura, Kadir, and Gomez have looked at this as well. It would be a combination of probably population density, stroke flash density, a bunch of other factors, so that we might be able to predict where we should use our resources in education to best facilitate lightning injury prevention and to teach safety behaviors. What behaviors should we recommend? Do wearing shoes or sleeping on a raised bed or things like that in developing countries, not in developed countries where we have plenty of safe areas to go to. But are these effective? Would they decrease the number or the severity of injuries? What's the effectiveness of the lightning crouch? Again, here's the book and a resource to that. It'll give you more ideas for research. In the developing world, we have no lightning safety without lightning protection. Again, to reiterate that, I've realized from doing this African work that there is no safety without lightning protection. And there are no easily available safe structures in most of the world. So thank you for your time. I appreciate it. And we really appreciate all the faculty who are speaking. Thank you. That's the end.
Yeah, thank you so much, Professor Marianne, for the nice presentation and wonderful job that you have done for this program. Thank you indeed. For any questions, I think we'll wait until question and answer session. Now, it's my pleasure to invite Professor Francisco Roman, almost on the other side of the globe from where I am. Professor Francisco Roman is a tenured professor and was vice rector of research and the Universidad Nacional de Colombia, UNC. His main field of expertise is gas discharge physics and lightning protection. He obtained his MSc in power systems at the UNC and has postgraduate studies at Karlsruhe Institute of Technology, Germany. He finished in Uppsala University, Sweden, his PhD and philosophy licentiate studies. In 1992, he measured for the first time in Colombia lightning currents in a 10-kilometer experimental transmission line. He has developed different devices based on the properties of floating electrodes and coronary charges, the Roman impulse current generator, and a high impedance current source. His research work earned him 7 patents, in 3 in USA and 4 in Colombia. To destroy from a safe distance improvised explosive devices that were used in the Colombian conflict, he was leading a project to develop a high-power microwave generator with the support of its university, EPFL, Uppsala University, Sweden, Universidad de los Andes, Colombia, and the University of New Mexico in the USA. Currently, his EMC research group is developing portable lightning protection shelters by using conductive textiles. I think Professor Marcos is ready. He has been visiting researcher at Gothenburg University, Sweden, the German universities Karlsruhe, it's a bit difficult for me to pronounce, and Munich, and at the Mexican Extra High Voltage Lab. He is participating at the lightning conferences, SIBDA, ICLP, and the International High Voltage Seminar, ISH. He was awarded with the most important Colombian scientific recognition in exact physical and natural sciences. In 2016, the ICLP conference in China recognized his dedicated service as a researcher and teacher and his remarkable contribution to the advancement of the lightning protection research field. Now, this eminent figure, I would like to invite and it's my pleasure to have him as a speaker on lightning safety for small structures. I would like to invite him for the talk. Professor Francisco, it's over to you now.
Okay, thank you very much. I appreciate very much your invitation to give my talk also about lightning safety for small structures and using the opportunity of Marianne Cooper, who is here, and Ron Holle. I was trying to speak more to a topic which could be of interest. Walk with your lifesaver. It means that it's possible that we could have the possibility to walk with a lightning protection device. Is what we hope in the 21st century. I hope it could be possible. This work is a common work. It's a research work of several scientists of our group, Electromagnetic Compatibility Research Group from the Universidad Nacional de Colombia. And the first one, Jorge Alejandro Cristancho, is doing his PhD, is writing his PhD thesis in this topic. Also, Professor John Pantoja, who is in Emirates now, Jorge Rodriguez, Carlos Rivera, Daniel Rodriguez, Fernando Diaz, who is also finishing his PhD on lightning location, and Liz Herrera, who is a mechanical engineering specialist in textiles. And we have also the industrial designer, Maria Barajas, working in our group. So the agenda should be background about lightning accidents, portable lightning protection, conducting textiles, and ongoing research. If we start with lightning accidents, of course, I'm very grateful that Ron presented this map before, and it's just to show that we are here, Colombia. We have a very high lighting activity in our country, and also thanks to Ron Holle, also we have this map. In the northern part of Colombia, close to Maracaibo Lake in Venezuela, and this northern part of Colombia, it has more than 64 strokes per square kilometer per year. It's a very high density area, but also almost all the country is affected by lightning, and also this yellow part should be more or less similar to Europe. And we have people sleeping outside in tents. Let me show with the laser. We have tents, people sleeping outside in this country, mainly because of the conflict, especially soldiers. And those are the hot spots that we have in Colombia. As you see, we have very large amount of mountains, very high mountains where we have several accidents. And you see the places where we have most lightning activity. So also from the work of one of our researchers shows the time of presentation and the hour presentation of thunderstorms. Most of them are in some regions, most during the night. That's why we are considering the problem of not step voltage, but head-to-toe voltages, because people like soldiers are sleeping on the surface of the ground, and sometimes we have lightning impact very close, for example, on the trees that are in the neighborhood. Therefore, this voltage, it's very important for us in the development of portable lightning protection devices or shelters. So this is one example of the geography of Colombia. You see mountains everywhere, and especially some places where, for example, people has to be here watching, taking information, and also protecting these masts. And we have had several accidents due to lightning on such geography. For example, here we have a tent. There was a lightning impact in this mast, this wooden mast, and 4 soldiers died here inside of this place. This is one example. Another example is a soldier also standing under a tree watching during the night, and the impact killed him also directly from the head. Also, this is an example of a soldier boot impacted by an indirect lightning discharge. You see the small hole, but this small hole, due to a step voltage, was able to kill this soldier. And the Colombian ratio between injured and fatalities is 3, it's around 3. It means that during a year, we have 11.7 fatalities. It means every month a soldier died in Colombia. This is from the 10-year statistics, so a few years ago, and almost 3 were injured. And thinking in Marianne Cooper presentation, we have all those people with problems after the lightning impact. What to do? This is something very important. And that's why Dr. Navarrete is also involved doing work in Colombia. Probably we can join our efforts to solve problems in this country. For example, we have this soldier survived. There was a lightning discharge and he was saved by his necklet. You see this metallic necklet was there, left some burn on his skin, and we were able to analyze the lightning current by doing experiments in the lab by obtaining the variation of the dynamic resistance of the chain, and we were able to establish the amount of current that was going across his necklet, metallic necklet. Also, with simulations on the skin, it was possible to see the temperature that burned the skin, and therefore we were sure about experimental and simulation values. It was a current of around 9 kiloamps because it was a indirect lightning. So therefore, we are going to the portable lightning protection. We start from this idea, probably you remember that. This is walk with your lifesaver. No? Imagine after, in the 18th century, after Franklin invention, people were walking with grounding connections, also very elegant dresses with ground connections. Le parapluie partenaire from the Barbeau du work. So what we are doing, we proposed a patent 2 years ago with Professor Felix Vega and John Pantoja. It was by using conducting textiles. And that it means that if a current, a lightning current impacts, this tent will behave like a Faraday cage. Also, it should be a grounding conductor here on the surface. And also they can use sleeping bag, conducting sleeping bags, and also mattress conducting. So the idea also could be to develop some portable shelters that could protect civilians also when they are exposed to lightning. But the idea was to study conducting textiles, and we start doing experiments in our university by using high voltage impulse test. And you see the impact of the lightning current here on the conducting textile, and you have the discharge here on the side. And when we observe the conducting material after this lightning impact, we start studying pieces of these conducting textiles 10 times 10 centimeter by using our impulse current generator, and by measuring voltage and current across the test samples, and also to have some photographs. And we observed that there were some marks on the surface perpendicular to the current flow. Here, for example, the impact was here, and you see these perpendicular marks to the current flow. And we start studying what's happening with this. Alejandro Cristancho went to Professor Alessandro Pantini and Professor Milton Chigihara in Brazil, in USP, and they made some experiments with these textiles, and there was voltage and current were in phase. It means it was a resistive behavior with relatively low currents, lightning current, 5 kiloamp. But by increasing the current to 10 kiloamps, there was a strange behavior of the voltage. And with 15 kiloamps or 20 kiloamps, you see that the resistivity changed completely. It means the material has changed his way of transporting current, and without that could be plasma discharges. Therefore, we continue our experiments. 1 year ago, we went to Sweden, to Uppsala University, and we were working with Professor Mahbub Rahman, a candidate, PhD candidate, Andre Lovato, and Professor Bernard Curry, who helped us to do the experiments. And we use this very high current generator, 10350 waveform, and we have here a test sample 30 times 30, and you see how the scratches appear. And also, we were trying to determine the maximum current density that could damage the material by applying also this current in the center of a conducting textile covering with a cylinder. So, and also we see exactly the scratches, and we start understanding that the conducting material of the textile vaporize, and the current start to flow over the surface across a plasma channel, which is produced on the surface. We have some examples here of some experiments that we perform later on in KTH, in Stockholm University, with Professor Marley Becerra and engineer Janne Nilsson. And you see here, when we apply the current, the material is completely destroyed, but the mechanical destruction came after the current flow. Here we have another example. You see now in the contact points, the material was destroyed. Another one. Let's see if we are able to activate this one. Oops. Okay, I think it's coming now. Okay, you see the material is destroyed, but mechanical events are slower than electrical events. And this is an example also made with Professor Marley Becerra and Janne Nilsson. Here we have a view, side view of the material. The conducting material is somewhere here, and we apply 8 to 20 current, 350 current, excuse me, several kiloamps. I don't remember how much in this moment. And this is a fast view. You see the material vaporize, current start flowing in a plasma channel, and current is also conducting, making a channel between the parts that are broken. So therefore, we think that in the future, we can learn more about this material and to see how we can use it in a safe way for the persons who are trying to be protected. So ongoing research, our ongoing research is trying to get the voltage difference between a person line and when we apply a current going over the surface here of this conducting material, trying to solve the problem of how high is the voltage between head and feet. So, and now we are developing also models of a person that, because we need to measure the induced voltage here on the body of this dummy, and now we are instrumented this dummy with oscilloscope and so on, and to see how is his behavior when the current flows. And also another important investigation is also what happened with this material which disappears after the current flow. And we have used some experiments to obtain the materials involved. And we see now that in this material was copper and nickel present, but there are some oxides that are involved that are also harmful for the people who is close to this. So as a conclusion of my presentation, we have observed that a high current density generates loss of conducting material and an increase in the material resistance. Second conductive mechanism has been observed when the lining current density increases. It's plasma, really. And from the experimental results, it can be inferred that conductive fabrics can be used in portable lining protection systems. This is what we expect. And our future work is to obtain the behavior of the dynamic impedance of the electroconductive fabrics. We have to do tests with portable lining protection shelters. Of course, that's why we are developing these dummies. and to see the problem of subsequent strokes, because if the material is destroyed, what's happened with subsequent strokes? And we have observed when we have a lightning impact on a tree, the current does not flow to the ground. It can flow over the surface and go directly to the shelter. Therefore, we have to think on possible almost direct lighting. And finally, standardization is the future work. So I hope that in the 21st century, we can walk with a lifesaver. Thank you for your attention. Thank you very much. I hope I was on time.
Yeah, thank you very much, Professor Francisco, for the wonderful work and your presentation and what you have been doing. And it's really inspiring to the new scientists and researchers in the field you have been working with. It was very, very wonderful to have you on the board. Now, before we wrap up, we have a discussion session, panel discussion session that will be conducted by Professor Chandima Gomez, who is the architect of all these centers across the globe, I would say. Solnet, Solnet, Jalsir, or so many centers around. So, Professor Chandima Gomez, I think, Marianne, would you like to say something before Chandima enters in?
No, I was just turning on my video and microphone for the Q&A session. But thank you to everyone who has presented. This is exciting. I'm so happy. This is the way it's turned out. It's great. It's great.
Professor Chandima, are you around? May I ask you to take over the...
Okay, thank you. Thank you very much, Sri, for your introduction. And I would like to thank first all the speakers today. You have done a great job, and all the participants. We don't have many questions from the participants at the moment, but I would like to invite you to either type your questions or ask any questions just by raising your hand, or even you can just unmute your mic and talk. But we have one question which was unanswered so far, which has been typed by Nazib Khadka, maybe from Nepal. Let me start from that question. It is to Professor Zainal. Let me first read out the question. I hope that Zainal is there.
Yeah, I'm here.
Okay, it says that, could you please elaborate transient fault detection? Is it required for transient stability study? As faults are detected by distant relays and faulty sections are isolated, as far as I know, what is the main point of using AI and big data in this domain? That's the question from Nazib Khadka.
Yes, thank you very much. I was about to type, when he first actually raised the questions. But anyway, the problem is that what happened with the, we call it the digital fault recorder, which is normally used in the transmission system that actually located at the substations, end-to-end substations. And what happened that this, most of the DFR, we call it the digital fault recorders, the sampling times, which is very, very low. And what happened is that if you retrieve the data later on, and you will realize that, say for example, the sampling is about 200 millisecond, and within 200 millisecond, you cannot see, or there's no more actually lightning, what we call stages, on that is actually overlap, on your normal sinusoidal. So this is the biggest, problem, and has been discussed in, IEEE and also in the CGRE, and actually they even came out with the standard and the guideline. But of course, now there are some digital fault recorders that is actually available that provided much more detail in terms of the sampling time, so that when there's a fault due to lightning, then you can actually you can locate and you can see the behavior and so on. and the opportunity of using AI, because another issue is that when it comes to the transmission line, you have no idea whether there is really bad flashover or the shielding failure, whether the lightning strike or direct hit to your transmission tower or your shield wire, or either it hit your phase conductor. So that's why we need to actually regenerate the all this data, and to use the artificial intelligence to train the data, and also to finally classify whether what's actually the actual phenomenon that caused the issue to the transmission system. So this is I think it's quite interesting topic. I think worldwide. In fact, some of the companies are currently doing and focusing in the US as well. So thank you.
Okay, thank you very much, Zainal, for your detailed answer. And I hope that Mr. Katka got the explanation he was expecting. So as there are no typed questions unanswered so far, let me start our discussion with the first question I would like to direct to Professor Marianne Cooper. Prof. Marianne, now one of the biggest questions that I got from few students, but big question I may say, because there is hardly anybody to answer these questions, especially when I conduct training programs, and when somebody asks this question, I'm really helpless because I have no knowledge at all in this regard. Now imagine that if somebody wants to come to the research on emergency medicine, let me generalize it to emergency medicine, although many people ask about corona medicine, because the people who ask this question are those who attend the lightning protection and lightning safety programs. So as I understand, in order to do specialization or research on emergency medicine, one should have a medical background. So can you please explain whether am I correct, whether somebody needs a medical background, or somebody like, for an example, I think there are few people like Chris Andrews who came to this field from non-medical side as well. Is it possible for somebody to do emergency medicine without having a proper MBBS? Over to you.
Good question. If you're talking about practicing emergency medicine, to practice any field of medicine, there will be national standards and standards within the specialty itself. And that varies by the country. So if you're talking about practicing emergency medicine, that's already limited by those rules. If you're talking about how do we look at injury prevention, because emergency docs generally are looking at treatment and injury prevention, then that's something that a lot of people can participate in. Ron Holle's participating in it. Francisco's doing wonderful work. Oh my goodness, this is exciting. My dream as an emergency doc would be to find physiologists, people who work in how does the tissue change? How are the chemical or enzymatic or hormonal changes that actually occur within the tissue? That's not something I have enough background in. I've got basic physiology as a physician, but not enough to know how to do the techniques. Just like you guys have the knowledge to do the techniques of high voltage engineering or lightning engineering, the physiologist would be the one that I would want to partner with to do this. So no, you don't have to have an MD to be a physiologist. And they have an understanding of how the body actually operates. So if you want to look at the physiology of what are the changes that are occurring in the brain, in the heart, in the nervous system, or those, get yourself a good physiologist who wants to do it. Okay?
Thank you very much, Prof. Marianne. Because this answer is very important because it is not giving the message only to those the participants at the moment in this program. There are about 75 odd participants, but actually this program, the recorded program, will go to a much larger audience, like 500, 600 people. And I'm sure that those who ask this question from me will definitely go through this, and your answer will be a very helpful tip for them. So that, and also they will get the idea that have somebody to contact if they need more information on that, because this is a field that I'm personally interested in seeing people coming into, because otherwise we are having a huge vacuum after the top guns hang their boots one day. So let's hope for the best. And then I would like to have another question, which is already asked by Foster from Ron Holle. But let me generalize it, because this is a question again and again and again. Many lightning researchers are asking from, I'm sure that from Ron as well, and it is asked from many lightning presenters in the world. If somebody wants to do research on the lightning statistics and to have a research paper to be developed in relating lightning statistics and lightning accidents, something like that. Ron, will you be able to help such students? If it is the case, then what should they do? Will they write you directly? Or is there a way that they can approach you? Or is they, or should they be approaching you through their research heads? Can you please elaborate on this?
Okay, thank you, Chandima. Well, in general, we provide data to, I'd say, substantial projects. As I said to Foster, we're not set up very well to answer one event at one time in one place. I'd like to very much do more of this sort of studies with other people. I can't do it all. I'm trying to do a lot of things. And we have this policy in place that Vaisala is supporting, and the data are available everywhere in the world. The network is global with no gaps. So what they could do is develop on their own or with their faculty member a specific project that involves a number of cases or a longer term study that can help identify what's going on. The limits are only two things. One is 5 years of data, and the other one is 1 million square kilometers, which is a fairly large area of most countries. So we provide the data in the form of one lightning detection event per line of data. And if you have 1 million of events in a period, you'll have 1 million lines of data, and you have to be able to handle that. Not everybody can, but each one of these data lines has the time to the microsecond, the latitude and longitude down to a kilometer or less than a kilometer actually, the signal strength, the polarity, and whether it was cloud to ground or cloud in the last few years. So it's up to the imagination of the researcher to take their idea and develop it into a project that is addressable. And we like to think that it's something that will result in a publication or a presentation or a thesis or a dissertation or a master's thesis or something like that. So they're meant to be for substantial research, so to speak. And we look forward to them. And I'm the one that manages that policy.
Okay, Ron. In other words, what you're telling is that whatever the collaboration should be in big time, it should be on large scale, not just to write a paper or something like that. Am I correct?
Well, yeah, if there's a very specific case, but it takes work to develop each time in each place, and then you come back and say, oh, I need to make the area bigger and so on. We're not set up for that sort of project. So yeah, contact me and we can work it out. I do this all the time.
Okay, sure. So I would like.
I have a comment.
Yes.
Yeah, sure, Colin.
Yes, hi, Colin.
So there are a number of networks, global networks at the moment. Some are commercial, some are research networks, and they have different detection efficiencies and different coverage of the globe. But I have access to two networks because I've helped set up the sensors, and one of them is a university network, the WWLLN network. I think also Anirban has a station in India. There's also Earth Networks, which is also a private company like Vaisala. But these data are also available for research for anyone. And anyone listening here could contact me if they're interested in that data. And basically, the data is available on a daily basis. So any day of the year, you can get the data, but it comes as global data. So you have to have the tools to basically filter out the data you want for your country, for your region, and do the research yourself. But the raw data we can supply. And on the smallest time scale is really a daily data.
That's wonderful, Colin. It's a very important message to everybody, and thank you, Ron, for you as well. Actually, my next question was to Anirban. I don't know Anirban is there, but I think the same question that Colin answered. I wanted to ask from Anirban how somebody from the South Asian region can start any research project or research paper or something with the data that they can access from his network. But Colin gave, I think, the answer. Anirban, are you there? I can't see you.
He's there.
Okay. Yeah, but anyway, it's
Yeah,
okay.
I am here. I'm having some problem in the connectivity. So sorry, I got disconnected in between.
No problem, Anirban. Yeah, just I wanted to ask the question that how can somebody get involved with your projects? Is there a way of you disseminating your databases or sharing your knowledge on or sharing your technology of lightning detection with the other research groups in the region?
Okay, so lots of VLF data are already freely available in the internet. Those links that I have provided, if anyone is interested, they can freely get the data. So these are data that no one has to pay anything. As far as other restricted data are concerned, then people have to come through a collaboration. Then the data can be accessible. But for young people who are aspiring people who want to come to this field, I don't think for them they don't need to spend a penny. They can just drop an email, and the resources that I have given, they can go through, and definitely they will find something interesting, and we can start from the free data that is already available. To many of the people share data actually. So data is not an issue.
That's wonderful. Thank you very much, Anirban. It's very good news for many research students and junior researchers who are involved with the field, not only here today with us, but those who are going to listen to this recorded event in the near future. And then I'm going to a very important question or important issue among many young scientists at the moment to Marcus. Marcos, I'm sure that this is the most burning question for most of the research students.
Fatima, sorry, let me interrupt for a second. Are you saying that you are addressing this question to a young scientist and you're addressing me?
No. Marcos, you are a young scientist. If you say that you are not a young scientist, it affects me and many others as well. Okay, so my question is very straightforward. If a student want to join your research group, are there any opportunities, scholarships, assistantships, research funding for such student?
The answer is yes, actually, in the sense that so Switzerland offers scholarships actually yearly from different countries. I mean, we need to see, I think they change every year, every few years, the countries, but you can spend 1 year in Switzerland doing research. That's one way. And if there is any, I mean, there is also the possibility, but this is linked to actually an existing project or to do PhD work also here. So maybe the best way would be to contact me or Farhad by email if there's any idea of anybody who would like to maybe spend 1 year here and or looking for a PhD work. I mean, this is highly dependent on the availability of funds actually for the PhD, but this is something that we can always talk about, of course.
Oh, wonderful.
Okay. Thank you very much, Marcos. As Farhad is with us, Farhad, would you like to add your views to
he was busy with another meeting. That's why I think he's there, but he's not listening right now. I don't know.
Farhad's muted. He's still muted.
He's there. Yeah. I know you're muted, Farhad.
Can you hear me now?
Yeah.
Okay, great. Sorry. Yeah. So I was able to be back. Yeah, I think Marcos, I mean, summarizes very well the possibilities. So there are these scholarships that are offered by the Swiss government for people coming over, spending like 1 year in either in industry or in universities. So this is one possibility, and actually the process of applying is, I mean, depends on each country. I think the best way is that interested candidates should contact the Swiss embassy to get all the details on the deadlines. Typically is in somewhere in September or October. And of course, what needs to be done is to prepare a research proposal, which is quite simple. I mean, it's like a 10-page research proposal over 1 year. And then, of course, if you'd like to come and spend some time with us, we can help them preparing this research proposal. And we need to basically provide a letter of support, also mentioning that, of course, we would be glad to host them in our laboratories. So this would be one way. The other way, of course, we, for PhD students, I mean, in Switzerland, PhD students are hired, so they receive a salary. They have to spend some time doing also teaching activities. So that means that, I mean, it's good in a way, but the other issue is that we need to secure funding for PhD students for 4 years. So this is, so if, I mean, we need to have some grants going on, I mean, have enough money to hire a PhD student for 4 years. Of course, the student should apply first to the doctoral program of the university to get admitted. And once he or she is admitted, then he or she has like 6 months or 1 year to find a potential host laboratory.
Okay, thank you very much, Farhad. That's very helpful tips for our students. And I think Colin would like to add something to this as well. And then I will come to Marcelo. Colin, are there any opportunities at your university for the
Yeah,
students?
there are always opportunities. It depends on the background of the student, the undergraduate degree. So that depends if the student is coming with an engineering degree or with a physics degree. If they have a master's degree already, or they just have undergraduate degrees, all of these will have different conditions, but definitely it's possible to apply. Generally, you should find an advisor, a master's or PhD advisor before you arrive, because it's not always 100% that you'll find someone if you arrive and you don't have a connection. So especially for foreign students, it's better to look on our website of the university, look in our department, look for a professor that may be interesting to work with, contact them by email, and then after you have the personal connections, it's much easier to get accepted to the program.
Oh, great. Thank you very much, Colin. And Marcelo, would you like to tell something from your side?
We do also accept students from different countries, from Japan, from US, from England, from many from Africa too. We have several students from Africa, and we have for master, we have 2 years scholarship. It's a 2-year scholarship, which gives them resources to stay here in Brazil and food expenses and all that. And for PhD, 4 years. It's a 4-year scholarship, all provided by the Brazilian government.
Okay.
The subject I'm doing my research now on lightning will be presented tomorrow. So, and my email is also there. So if anyone is interested, just email me and we can start talking.
Okay, great, Marcelo. That will be quite helpful. And this is a precursor actually to your presentation. And I'm sure that many interested students will attend tomorrow. And before I go to the next question, let me ask Zainal. Zainal, are there any research opportunities at either UPM or UNITEN for the students from other countries now?
Well, yeah, I mean, in general, I mean, it's almost like every institutions they have their, I mean, what we call the opportunities, but of course, we do have also some limitations in terms of the funding, and I think most of the time that I think most of the students basically who came here, they already have or they already secured their scholarships either from the government or from the company or from the institutions. But yes, we do have. And in fact, we do have also we call it international mission scholarships, for international students. But most of the time, at the institutions initiative, UNITEM, for example, the what we call the electrical power utility who own the UNITEM, so they actually provide some funding for the PhD and master students, and in fact even for the degree students as well. So likewise for other institutions as well. So it depends, but I think as what has been mentioned by some of our colleagues just now, that they can actually communicate, by emailing, or going to the website and email the respective person in charge, and you get a better picture of that.
Okay, thank you, Zainal. Let me give a additional recommendation that UPM is a wonderful place. If anybody would like to join, it was my home and still I consider as my second home. So it's a wonderful place. If you decide to join there, you can write or drop an email to Prof. Zainal Kadir and he will help you. And
thank you. And you should.
Yeah. Okay. And The next question is to Francisco. Actually, Francisco, this is not for the students. This is actually something that I want to know. If a research group is going to have a collaboration with you, what is the procedure? Is there any opportunity to have a joint work with you? And are you open to the others for joining your research?
Thank you for your question, Shandima. You know, when we start studying, for example, radiating electromagnetic waves to destroy landmines for the peace in Colombia, we got help from Sweden, Switzerland, the USA, Germany. Several countries have helped us, and we have learned that the highest degree of solidarity, and I think this is a principle that we have to follow, share knowledge. It's not a question of money, but it's more knowledge. And I see, for example, in this presentation of Ron Holle, that he's giving for free the information of LIME. It has helped us a lot to start work and so on. Therefore, we are completely open for several opportunities to work with other universities, with other groups, and so on. Because we have also understood that, understand that in every country you are able to produce knowledge, and also this knowledge has to go out from that place. For example, we are working in interferometry. This one of our researchers, Fernando Diaz, is working in interferometry, and he's also producing a new way of detect the development of lightning on the clouds. And this development could be also, it's going to be patented, but also it can be shared because it's not too expensive, and knowledge is a question of individual persons. As we know, when we were in Uppsala University, that we were from all over the world working with the same idea. And I think this is the opportunity of the COVID that we have to use to work together to solve problems. This is my comment, Shandima.
Okay, thank you very much, Francisco. This is very helpful. Even for me, we will have another personal discussion in this regard, and all the other interested parties can also join this research. You can contact Professor Francisco. And I think before going to the last question, the penultimate question, I would like to direct to somebody here in this event attending. I think it is I'm not fulfilling the requirement of my university if I don't do that. Professor Ken Nixon, my brother professor who is here, my colleague, Ken, can you give some idea about how a student from Africa or from Asia can, or from any other part of the world, the opportunities that they have at Wits University, the University of Witwatersrand, if they are going to join, or if they are interested in joining our university? Ken, are you there? Okay, it looks like Ken is not available at the moment. Maybe we can take this question tomorrow then. So that I'm going to the last question.
Oh, Shandima,
Yeah.
Hugh Hunt is on. Ken is not.
I am on.
Oh, yeah, Ken. I'm sorry.
Oh, can you hear me now? I'm so sorry about that. No, I've got the question. My microphone clearly had a problem.
Oh,
So
okay, no problem. Please go ahead.
apologies for that, the wonders of technology. But I think, thank you, Chindima, for the opportunity. And I think, like everyone, we live in a world where the more people we can speak with and interact with, the better. And again, our university's got a strong international office. We've got various schemes that, that will support all the different levels, from a postdoctoral student down to master's level. And I think, as everyone said, it is, I think, dependent on the interest and the project. There are some issues around funding always, and finding that can be a trick. But I think there's a lot of opportunity and a lot of ground that we have in common. And I think what we've been learning in the observations we've been making locally is we've got some good observation sites in terms of lightning activity in general. So it's quite an exciting, let's call it a living laboratory to work in Johannesburg in particular. So I think, thank you for the opportunity, but anyone's welcome to contact me or you, and we'll direct them and guide them through the process. Thank you.
Thank you very much, Ken, for your input. And I just noticed that Miranda, you want to raise a question, so the floor is yours.
Hello, everybody. Is everybody listening to me?
Yes, you're audible.
Well, my question is a technical question, but first of all, I'd like to anticipate my congratulations to the organizers and to all the speakers. And I also would like to apologize for the fact that since for the beginning I was in this meeting, but for technical issues, I could not listen to a call that Dr. Sriham made to me. Well, my question is to Dr. Anirban Guha. Is he still there?
Anirban, are you there?
Yes, he is there, but muted. Anirban.
You can ask the question. Maybe he is listening.
Okay. As I told you, it is a technical question, and I asked the space for making this question. Well, in his presentation, Dr. Anirban Guha showed some plots, and one of the plots, I believe it is an electric field waveform with some pulses. And I would like, what kind of information could he obtain from exactly that waveform showed? Because I saw some pulses. I understand that we can use electromagnetic radiation for lightning location. But from that time series, is there any project in order to develop an algorithm so that only looking from that wave shape, that time series, he can detect strokes or lightning, or from that that event, that waveform, by looking, he can detect only strokes. And the second question is there any project about of how can we use that kind of information for lightning safety instead of recurring to lightning location systems? I already know that lightning location systems has a very, very good algorithm to work with this kind, the electric field waveform, magnetic field waveform, but something that we could do less dependent on the lightning location systems, which are very expensive, and we can do only looking these wave shapes. and I would like him to the responses, the answers.
Okay, thank you very much. Miranda, first of all, can you give a small self-identification for you?
Sorry?
Can you give a small detail, I mean, introduction to you?
I am identified as Miranda, but my first name is Fernando. Everybody can call me Fernando. I'm from Brazil, from the Universidade dos Vales do Jequitinhonha e Mucuri, or Federal University of the Valleys of Jequitinhonha and Mucuri. And it's located in Diamantina. It's a city in the state of Minas Gerais, Brazil. Is that okay?
Okay, thank you very much, Fernando.
Okay.
Fernando is a very familiar name for me. So, my original country is full of Fernandos. So, Anirban, over to you.
Sorry?
No, I'm asking Anirban to give the response. If Anirban is not available, may I invite Colin? Colin, will you be able to answer the question?
Okay. No problem.
I don't know if I understand it 100%, the question, but the last part of it, you were talking about not having to use lightning networks for protection. And this is possible to do if you simply look at electric field meter, basically the DC field, which is in fair weather will be about 130 volts per meter towards the ground. And as a thunderstorm approaches, the polarity will change and the fields will rise up to kilovolts per meter. And that is probably the simplest and best way to protect yourself or your surroundings from, or to know of the dangers of a storm without actually knowing the exact location of the discharges or the flashes. And they use this sometimes, for example, on golf courses. So you can put a simple electric field meter on the top of a house or something, and when the field passes some threshold, it can turn on an alarm and warn you about approaching storm. So it's maybe less accurate and won't give you the exact location of the lightning, but it will give you a warning that storms are in the neighborhood. Regarding the pulses, whether it's strokes or flashes, I think all lightning detection networks detect strokes, and then you have to somehow bin the strokes into flashes, either by the location, the difference in the distance between the strokes and the time interval. But all lightning networks which are detecting the EMP pulses are detecting strokes.
Chandima, if Ron's on, he's done a lot of work or is aware of a lot of work of lightning safety detection systems, like for airports and other venues. So we might ask him the same question if if people are interested in what are the practical detections or forecasting, or where is the lightning within 8 kilometers of me, so I have to do something for safety. So, Ron, are you there?
Yes, I am. Yeah, we've done quite a bit of work with lightning detection networks and a little bit on field mills. It's gotten to the point where a lot of places like airports and high-end users, such as recreation situations, are looking at every minute of downtime as an expense. I think the number is $5,000 a minute for some airport operations. And so it is very much possible to use detection networks with range rings and various thresholds to identify exactly when the threat is nearby and when it's leaving. The field mills are sometimes used to augment for overhead storms, but we found that there are so many false alarms with field mills that it sometimes is not too productive. It's a helpful but not sufficient addition to the data set. I have a lot of publications on this using networks, and it's an ever evolving set of questions. Just when we think we've answered everybody's questions, they come up with another way of looking at it. And there is quite a decent amount of literature on that, and let me know.
Chandima, this is Anirban. Sorry, I could not comment at that time. So
no problem, Anirban. You can go ahead now. And thank you
yeah,
very
so
much.
can you repeat the question?
Fernando, can you repeat the question very quickly? The basic question.
I will formulate the question anyway. Well, in your presentation, you showed an electric field waveform as an example of the kind of data you work, isn't it? So that kind of electric field waveform you showed us, I noticed maybe 3 or 4 pulses. And
yes,
without recurring to location systems, location network, lightning location network systems, could you use only that waveform to identify, for example, if you have a lightning or only strokes? For example, you have 4 strokes, for example. Could you distinguish if one stroke is of a certain lightning and the other stroke is of another lightning, only using this waveform without recurring to the potence, to the powerful algorithms of lightning location systems?
Okay, so
and
so
how
there
could you use this? How could you use this to lightning safety? If it's possible.
So is it okay? My bandwidth is not good. So is it okay if I just don't share my video? Is it fine?
Fine, it's fine.
It's fine.
Yeah.
Okay, no problem.
Okay.
Okay.
So as far as I understand, you would like to know whether we can use only the information from the lightning stroke pulse to determine the distance of a lightning stroke. So from one pulse, it is possible if you know the dispersion relation. So there are papers, and we tried that, and also we can do. And if we have 3 or 4 receivers, and they analyze the distance, and then they triangulate that. So in order to do that, we need to go in an intermediate or far zone in the radiative field. That means if we are too close to the stroke, within 100 kilometers or something like that, then the ground stroke will dominate, and we will not be able to use that method. But if we go to intermediate and far zone, then from the dispersion relationship, we can look at the phase frequency spectrum and calculate the approximate distance from one location. And from 3-4 locations, if we have 3 distances, then by using triangulation, we can definitely do that. So yes, from dispersion relation in the VLF, we can do that. If I understand your question correctly.
Okay.
Okay, thank you very much.
Thank
Hope
you.
that Fernando got the answer from 3 experts in the field. You got the explanation for your question.
But I'll be very happy to discuss over email if my answer not clear. So we can discuss later over email channel.
Okay, maybe by mail, and if we have enough time, I can express better my question too.
Okay.
Okay.
Thank you very much. Thank you.
Thanks. Sri, do I have time to pose one more question?
I think we are running short of time, but for other queries and videos sharing and all, I have posted an email on chat box so that the participants can use that email ID to share their questions, and you ask for the videos, request for the videos. Yes, go ahead with the question very quickly.
Sure.
Okay, actually, this is a question for 4 people. So hopefully all of you could give the answers very, very quickly. This is very important for our students, especially the students and the researchers as well. At the moment, we have today 4 people representing international lightning research centers. From McLeanett, Mary Ann Cooper is there. From Solnet, Sriram Sharma is there. From Zaklir, Foster Lubasi is there. Then from CELP, the former CELP and now ALPA, Prof. Zainal Kadir is there. So my question is, can you briefly tell our audience how can a research center or Lightning Awareness and Research Center can help anybody who would like to do research? Apart from your awareness programs, how could a student or young researcher who want to get involved with lightning research, how can your center can help such student or a researcher, especially young researchers? Shall I start from Sri Ram, then I will go to Foster, then to Zainal, and then finally to Marianne Cooper. Over to you, Sri.
Yeah, thank you so much, Chandima, for your question and letting me in. Actually, the Lightning Research Center or South Asian Lightning Network has been working towards not only towards raising awareness and training to the engineers, but also is committed to bring the students together for the research activities as an effort and as a initial step. I have already collaborated with, for the Solnet, we have collaborated with the International Science Program of Uppsala University, and we have been working on various projects and proposals to get actually the major issue for us is to get the fundings. Fundings is the major issue, and in our part, particularly in Nepal, the students, PhD students, has to pay for his registration and everything fee. It's very pity that students has to pay, and they cannot. They have no way but to run away from the country. So, in order to keep them in the country and in the region, we are trying our level best to get the fundings, and actually myself and Anirban, we are together. Recently, we have applied for a funding from the Energy of Department of Energy in the US. So hopefully, we are very hopeful that we'll be getting some fundings from there, and I am particularly connecting with various personalities like Colin Price and then Farad, Marcos, and other people from around the world to connect my students or our students to get them into the research activities. But the problem is funding. Yes, we are supporting the students from outside. Thank you, Chandi. And it's Foster.
Okay, I can come in. I can come in now. Yeah, thank you, Chanma, for that question. For Zambia, actually, what we're doing right now for everybody's knowledge is that we, with the help of UPM and Professor Gomes, we have introduced a master's and PhD programs in electromagnetic compatibility and high voltage at the University of Zambia. So right now we are in a serious recruitment program. We're trying to encourage students and people, even professionals, to register for these programs. And actually, as Zachary, what we are doing is like what I'm doing right now, looking for mentors for our students. I think we will definitely contact most of you and link you up to some students that you can encourage them. And it's just a pity, I just noticed two students in this webinar, but I had invited quite a good number so that they can see these opportunities and the viability of the lightning research. So I think basically that's what Zachary is doing. We are encouraging people and we would like to expose them to people like yourselves so that you can help them. Thank you.
Okay. As for CLP, I think CLP, we've been like almost like 12 years basically since we established a CLP, and now it's become one of the top 2 center in the university. But I think one of the key important criteria is because that's actually determine continuity of the program of the center. And also, I'm happy to say that most of the bets that we have at the center, I mean, for our postgrad students, are actually driven by the utility, driven by the regulatory body. Sometimes we have the standards, and it comes to the what we call the idea from the regulatory body, for example, on a certain aspect in the standards that needs to be investigated. And it also actually triggered the interest of their staff, to come to us and to do their PhD or their masters. So this is how it works so far, and it works very well. But at the same time, I'm also happy to say that I think with the international collaboration and networking, we do have access, to data, to almost to any data, I would say, either from local data, from the power utility, or from even lightning data. We do get some data from Prof Rakov last time, and also we get some information from Prof Rashidi and Prof Rubinstein also last time. So I think as I mentioned, this is a very good platform for us. It's not just to I would say for the benefit of the student, but also for the benefit of the public as a whole, so that whatever that we do at the center, we can also share at different platforms such as ICLP and so on. So I think so this is how it works at the center, because we are not working in silo, we are collaborating, we are getting all the information, all the data from the utility. So I think so far it works wonderfully from that perspective. So we have no issue for the students, to complete the PhD or their master on time. So we are very pleased, the fact that we have laid the foundations at CLP for the past 12 years, and it's still going strong. So at least that is our milestone or our achievement, for now.
Professor Zainal,
yeah.
Do you have any opportunity for the students to have a sandwich type of program?
Yes, we do have actually, but of course at the administrative level, then it normally will be carried out by the School of Graduate Studies. But normally we are very much open for that opportunity, and we do have the even joint degree program with Sheffield University, for example, with Imperial College. So yes, we are, and then we did have last time 5 years, I would say, MOU with Uppsala as well, with Vernon. So with that kind of thing, it depends. So yes, we do have, we are looking forward, in fact, for any collaboration, either at the center level or at the university level, no problem at all.
Oh, wonderful. Okay, thank you. Professor Mariana.
Okay. I would like to take the opportunity to thank everybody for participating. And you may wonder, what's this weird doctor woman doing with all these lightning people? Well, it's just because you all are such nice people, and you share your information, and you share your knowledge, and you share your time, just like you've done for this conference. As far as ACLE Net, we're not doing lightning research in the physics and engineering areas. We're really doing it in the people-based areas. How do the injuries occur? How do we prevent them? How do we get the information out to the public and change their attitudes and give them behaviors that they can use? So I can help you with any of that. But in addition, because I've been hanging out with all of these people for the last 20 years, if you want to contact me, I will get you connected to whoever can help you. I think most of the faculty on this program would say the same thing. So it's a really nice community. Thank you all for your friendship for all these years.
Thank you very much, Marianne. You are the inspiration for most of us. And I'm sure that the generations to come in this field will remember you. And thank you again for all your wonderful work. Long life. And
God be the glory. Thank you.
we'll do together. And with that, I will complete my duty, and the mic is over to you, Sri Ram.
Okay, okay. Thank you so much, Professor Nima, for this session. Now, before I would invite Mrs. Foster for wrapping up and vote of thanks, I would like to announce that tomorrow the program will be rather interesting, and I would like to invite and request all the speakers that are present today to be there in the panel tomorrow as well, so that we make the program rather lively and more interesting. And it's really our pleasure that we have all very nice people from around the world, or even though they have devoted their lives on lightning research, they are with us. So they are always ready to help us and our students. And I'm very happy that recently Professor Farad has accepted one of my students to his department. So he'll be doing PhD in the days to come. So with this note, I would like to invite and request Mrs. Foster Lubasi to wrap up the program and give a vote of thanks. Mrs.
Hey.
Lubasi.
Yes, I am here. And I'll just like to say, wow, I'm sure you would all agree with me that this has been a super great seminar. And I'm quite excited, actually. I'm sure I speak for most of you. I mean, we've heard a lot. For most of us, it's really been an eye opener. And I mean, we've got a lot of very useful information, very interesting ideas. And I'm sure that from this webinar, we will have a lot of networks, come up. And therefore, I would really love to thank our distinguished speakers, but of course, our distinguished organizers. Thank you, Chanma. Thank you, Mark, Shri, for the great job that you've and the great work that you really put in to bring this event to pass. And to our distinguished speakers, we're so grateful that you could actually say yes when we called upon you. We thank you for sharing your knowledge with us free of charge. Only God will reward you for this because you have no idea what you're doing, especially for students in the developing world who cannot afford to pay for this kind of information. We're so grateful to you. And you did it in such a lively manner that it was actually a wow. So I'd really like to thank you very, very much from the bottom of my heart. And to you all, our distinguished participants, thank you for taking time to listen, to participate, to ask your questions, and to just be here and attend this seminar. It was such a great success because you were here. So I would like to thank you very, very much. We hope to see you again tomorrow. For now, take care and God bless. Thank you, Shri.
Thank you so much, and good night from my side, and take care.
Thank
Good
you.
morning. Good morning.
Thank you.
Bye. Thank you. Thank you. Thank you very much.
Okay. Bye-bye. Thank you.
Bye-bye.
Bye.
Thank you, everybody.
Thank you. Bye-bye.